Hello. Hopefully it's working. I'm using a different microphone today. Using my new microphone. I think I've got it tweaked okay. So let me know if it sounds a bit bad or anything. Also, I'm not sure how this stream is going to go. I might have trouble with connection speed because I don't normally stream this time of day because it's like peak time, so peak internet time, and it may struggle a little bit. I've got the settings back down, but I've already seen it dropping some frames and stuff, so we'll see. Here we go. I do have some headroom here to drop it down a bit, so fingers crossed. Audio sounds okay, that's good. I mean, for comparison, I'm going to switch between mics. So this is my new Saramonic microphone, which I did a review on the other day. Published that a few days ago. And if I switch mics, this is back on the Samsung mic, which is what I'll normally be using to give you some idea about audio quality difference. So either be this mic, which is what I normally use, well, used to normally use, or the new Saramonic microphone. So I don't know which one sounds better to you. It's a bit hard for me to judge. I mean, I've done some A/B recording testing, and I think I prefer the Saramonic, but I don't know. So I'm not quite sure what I'm going to do today. I've been trying to sort of figure out what I'm actually going to do in the video, in the stream. I'm just trying to get motivated. I've got a whole bunch of mailbag stuff over here. Let's click to that. I should quickly show you that. Yeah, I've got a pile of stuff there, which we'll probably open that up. I think that would be something worth doing. Did that clip then? I think it might have clipped. Yeah, slightly. So, yeah, I'll probably do that. And more background noise. Yeah, I've got more gain on the new one. The new one's a sort of a generally quieter mic, and I've got a lot of gain on it. So, I think it does better close up. Let's drop the volume down to -5 dB because I've got 6 dB gain and an EQ on it to try and cut out any thumps and like bashing on a desk, stuff like that. Also done some modifications to it to put some rubber feet on it, because part of the problems I had with this mic when I did the review on it was very sensitive to any knocking on a desk and stuff like that. You probably heard it in the review if you watched that video, and any bangs on the desk, it really showed up. So I've modified the microphone bracket. In fact, I'll swap over and I'll discuss it. Back on the Samsung microphone. So, and I'm all tangled up. Hold on. Right, so what I did is on these screws here, they were straight onto the frame. So there was actually like no rubber bushing between the frame, the screw and the microphone, because anything would have travelled through the frame, through the screw, straight into the microphone and made it bang. And the impacts and stuff went straight through it. So what I've done is I've drilled bigger holes inside the frame. And those brackets, I drilled bigger holes in there, and I put some grommets inside them. So these are now completely rubber mounted. That's completely rubber mounted. There's no physical direct connection between the frame, the screw, and the mic anymore. The screw and the mic are obviously connected together directly, but I've got a rubber grommet between that and the frame, so it should help reduce anything. And I've also put some ugly rubber feet on the bottom. Nice big chunky rubber feet, and that has actually basically taken the desk bangs and stuff down to almost nothing. And then I EQ'd as well to take the bottom of it off in the end. So yeah, I mean, from what I've heard, I think I prefer the sound of the Saramonic, but they say it does pick up a bit more noise in that way. So go back to that one. So back on the Saramonic again. So yeah, yeah, it's just a bit different. So it's complaining about drop frames again, so it drops my frame rate again. That's reduced my stream output. It's struggling, like I said. I thought it would struggle this time of day. So at least I've reduced my stream throughput. It should even out a little bit. I did actually find in the mornings, which is when I normally stream, the bit rate was a lot better. I could actually crank it up quite high. So yeah, so I've just backed down my bit rate a little bit, so hopefully it should be a bit better now. Might be slightly less quality as well. Sounds compressed a bit. Yeah, it could be. Yeah. So I've got 6 dB gain on that, but I've actually just dropped the level down by 5 dB. So it's kind of equaling out, because it did seem quiet to me before, but then I was just sort of doing my own testing, not actually talking properly, you know. So let's drop it down to 6 dB. That equals out that gain, so it should be basically what's coming from the mic straight in. Andre, how's it going? Should say hello to everyone as well. So we've got Dave, Michael, Johan Radio Guy was here, looks like he's going to come back later on Jim as well. So Paul's not streaming, so Jim's here. So right, well, we'll see how this goes anyway. I mean, it's the level's looking better than I thought it was going to be. That's why I backed it down now. So that should reduce some of the background noise slightly. I do have it EQ'd as well to drop that bottom end off. And if it does sound a bit too top end, I can EQ that off as well. But I think the best microphone, I think Ian said it in my review, was the microphone on my camera actually sounds best. The one that's actually built into my camera. The built-in mic sounds really good in my camera, the Canon. And so that's why I don't use a power mic or anything like that, because if I do use an external mic with that camera, it doesn't actually sound as good, unless I'm at quite a distance from it. Oh yeah. Anyway, so we'll play around with some stuff. I'm not quite sure what to do yet. Oh, you're watching Lewis's stream. Yeah, I did see you on Lewis's stream actually. I did say hello, but I don't think you saw my comment. He's laying in bed, talking about things. I wasn't there long. It was only, I don't know, 10 minutes I think. Probably not even that. I was fiddling around some other stuff at the same time. So yeah, so we've got mailbag we can do. Kitty, yeah, it's Kitty. I've got my cats now. Well, there's one of them over there. The other one's asleep over there under the table. You probably can't see it. There's a cat right there, asleep under that desk. There's another one underneath my desk over here where I normally work. She's just sitting there looking around right now. She's the really skittish one, which I showed in the review video. Yeah. So this one sounds clearer than the other mic, does it? That's good. Yeah, I thought this one did sound slightly better. Just because on the Samsung mic, what I have to do on that one, if I have it as a directional mic, it's a lot quieter. And although it gets less room noise, you know, you have to have that volume difference. So I do tend to run that one as an omnidirectional microphone, which then it picks up the room noise a lot more. And it's actually really good as an omnidirectional mic, which means it's actually good when I'm working around the bench or doing these live streams or I'm changing from place to place, where it needs to capture me wherever I am in the room. Now, I don't know how the sound monitor is going to go at that. I mean, I've got it gained up and stuff, as I said before, but now I've now turned it down a bit. It seems to be doing a bit better. That's like arm's length from here. Well, here, like my arm, it's just about touching it there. Right. So when I'm at the other desk, I'm about the same kind of distance away. So I'm hoping it will still be okay when I'm over there doing stuff. So it'll still hear me okay in the stream. Anyway, that's the plan. So like I was saying, I think about doing a live mailbag, like a behind-the-scenes mailbag. I've got 9 packages, I think it was. I've got there. One of them has got a lot of stuff in it. It's some parts which I picked up thinking I might need them for my Datron calibrator. It turns out I didn't need any of them. So I've spent about, what was it, $400 US on an assortment of parts which I may or may not need, because they're obsolete parts. Makes them a bit more expensive for a start. But at least now I've got them, so I don't mind doing that sort of thing. If it's something I'm keeping, like the calibrator, I'm never going to be getting rid of that. So that is going to be something I need to maintain. And so in the future, it will need parts. And, you know, if it fails in 5 years' time, you might find you can't get those parts at all anymore. So I don't mind spending the money now and getting a stockpile of parts, which I may or may not need. You know, initially, obviously, it's a big expense for no benefit. But down the road, it'll be a good thing. So... And that's where the people that support me and send me donations and my Patreon supporters, stuff like that, and members on the YouTube channel, the money from that helps me to buy these things and do these, I don't know, extravagances, I suppose. I suppose there's an extravagance, buying a whole bunch of parts you don't need yet. Is it future-proofing? Which one is it? Extravagance or future-proofing? You tell me. Nice lab. You haven't seen much of it yet. Yeah. I don't know, you may have seen other bits of it as well. If I've done other shots, previous other videos, you've probably seen it. But for right now, you can't see much. Because it's basically over there. You can't see it. This is a shared office. I share it with my wife. So my wife is over there. Hey, Jim, you became a level 1 member. Thank you very much, Jim. Excellent. Now you get the perks of getting videos ahead of time. I've got a special playlist, Jim, so watch out for that. I've got a playlist called Membership Early Access. So members have access to that. So it's my Patrons, I post special links on my Patreon page for Patrons, so they will get to see them explicitly on a dedicated post on Patreon. Whereas YouTube doesn't allow to do that, so what I have to do on YouTube is do a playlist which is hidden from everybody apart from members. So members can then see that playlist and they can then see the videos ahead of time as well. So watch out for that playlist. I'm doing radio work these days. Well, I should be. I've mentioned this many times, I'm sure. I've got about a dozen radios out in my other lab, which is my RF lab, which I've got set up, which I really need to actually do some work in. Which were all the flood damage ones from I had in that flood, you know, from a few years ago now. 2 years ago, was it? I don't know. Anyway, yeah. So the radios I got from that, which were flood damaged, I cleaned them up at the time and just tried to minimise the damage and dried them out and put them away. And I did a bit of work on some, and I kind of radios are okay, but there's no money in it. And I'd rather be playing with test gear. Test gear's far more interesting. So, yes, I do have radios to do. I do intend to do radios, and I do have some footage already recorded. But there's a radio I've been working on. There's a Cobra, I think it's 29. 29 Limited, I think it was. Limited Classic, one of the newer ones. I think that's what it was. And that's got some kind of weird audio problem where the transmit audio is extremely weak. And it seems to be an audio transformer problem. It could be shorted windings. I'm not quite sure what's going on there. If I modify the transformer slightly, I can get the transmit audio really good. But then when the receive audio is actually garbage. But if I leave the transformer alone, then receive audio is fine, but transmit is rubbish. So something's going on with that transformer. Something's not right with it. I'm suspecting it's got some shorter turns or something like that's going on with it. So I really need to put a new one in it. But I don't have any junks Cobra 29s right now. So I don't actually have a spare one to put in there. Because also I lost a whole bunch of my junk radios as well. My spares radios, I had a bunch of them in the box and they got flooded. And I just like, well, no point using those as parts now, so go on. They ended up getting shut out. Do I work with Arduino? Yes, I've done a lot of work with Arduino and ESP32s. I prefer the ESP32 to Arduino, but I use the Arduino IDE for the development of stuff I do. For example, this box here has got an ESP32 in it, and a LoRa module, and lots of dust on the top. This was a keyboard interface, so you plugged a USB keyboard into it, and this then used the LoRa module to remotely communicate with the web server. One of the projects I've got lying around. Yeah, nothing else convenient. But yeah. Yes, I thought I'd just try a different time of day. You know, like I mentioned in the last live stream I did a couple of weeks ago. I thought I'd try streaming a different time of day. It may not suit everyone. It may suit some other people better. It may capture a new crowd. I thought let's give it a go and let's see how it turns out. Whether it's better or worse, whatever. And hopefully be okay. If it doesn't work out as well as a normal stream, then I might revert back to my normal time. Who knows? I may even do another one tomorrow morning in 12 hours time. Who knows? Unlikely, but you never know. So I was thinking mailbag, as I've said a few times now. Mailbag, do a behind the scenes mailbag review. So I'll probably do 2 videos from that. I could probably do 2 mailbags from that because I've got enough stuff there. And then I've also got a couple of projects I could potentially do. I've got a broken MacBook, which was working. It just dead. It won't power up. Won't turn on. This is a MacBook I fixed about 2 years ago, and it's been working absolutely fine since then. And I last used it, well, I tried to use it about a month ago. It was dead. Just wouldn't power up. So that's something I do want to look at. I need to get that fixed. I've also got a Datron 1062 multimeter over there, which I need to refurb. Basically needs recapping, so it's not going to be too exciting, but it's also not too involved, so it's a nice, easy one to do. And then I've also got the Datron 7075 multimeter, which I've got sitting down here as a project to do. That needs the socket on the front changing. So I've only got one cable, which I want for my Datron, which is sitting up here. Because I want to sell the 7075, but I only have one cable, and the cable's expensive. And well, mainly the connectors are expensive. So I'm going to swap that connector out with another one, or if that doesn't work out too well, go to B and C sockets instead. So that's the options I've got there. So yeah, these are all little projects I've got queued up. I've also got another thing under here. What is that? That's a null meter of some kind. What the hell was that? Can't quite see what it is. Is it 893A? Something like that, was it? Yeah. The Fluke 893A null meter, which I've had sitting in for a while. That's a project which, it does seem to work though, but also I would like to pull apart and refurbish it and redo the caps, that sort of stuff. So let's see, Ham International 2, someone dumped on me. Someone dumped on you, Ham International 2, oh yeah. Is that the one that's got the 50 channels per band? This one's got 50 channels, I can't think which one it is, instead of the standard 40. Random timer, right? Yeah. How's it going? And which membership, YouTube or Patreon, gives them the best bang for buck? YouTube take about 30%. Which is why the pricing I've got on the YouTube memberships is actually a bit higher than the Patreon to try and balance it out. Patreon also take a chunk as well. I did used to have a $1 tier. I've now limited that one, so anyone already had a $1 tier gets to keep it. But I now start a $2 tier because the Patreon takes a bit of a chunk and it ends up not being much. So, but that's something like a monthly payment as well. But I think I've got 1, 2, 5, 10, 20 and 50, I think that's what I've got on there, something like that. So, yeah, I don't know. Whichever one's most convenient for you, it doesn't really matter. You know, anything I receive from donations is appreciated because it all helps. I use it to buy like stuff in my bag and bits of test gear. You know, it also contribute to me buying test gear. Like I've just bought a few things. I've actually just bought some. What else did I buy? I bought a whole bunch of stuff. I bought a Peak Electronics tester, DCA 75. It's like next model up from one I've already got, which is 55. The reason I bought that is because I needed it to test JFETs. My current meter couldn't really test it. It only gave me a gate indication. It didn't tell me whether JFET was okay or not. And I needed that really for the Datron calibrator because it's got JFETs in there. And as a problem I was chasing, like, did I have bad JFETs? And I had no way of really testing them. So I bought one of those. That was over a week ago now, and it's not actually moved yet. It's been picked up and then disappeared. So you know, that'll come eventually. I bought. God, what else have I got coming? I think now I've got some. I put up some nice cables actually. Some like clip probes, gripper things for doing test points. You know, we're going to test points on boards, stuff like that. There's some HP ones on eBay. A bit expensive for what they are, but they're quality ones. So I thought, well, yeah, okay. So I bought some of those. And the other thing is they've got some nice long cables with them, and they're coaxial cables. And like individual, really tiny little individual cables for each hook probe. Now, I don't actually need all of that stuff. What I do want it for is my new Siglent oscilloscope, which I picked up, which I won the other day, you know, a month or so ago now. That's got the MSO option on it. Well, it does now. And I need the probes for it. Now those are using passive probes and active probes, so instead of having a digital control circuitry or balancing circuitry and stuff like that inside the probes, like my old 2000 series did, they're passive probes, so it's basically a connection system. Now someone has actually developed a DIY probe solution, and it's on the EV blog forum, and I was looking at that quite closely, thinking, right, well, I could buy the probe, like a pre-made Siglent probe, which is very nice, but it's expensive for what it is. It's just a hookup solution. So I thought, right, if I buy some obsolete HP logic analyzer probes, because they've got the right wiring on them, got the right hookup system, it's all exactly right, I could use those with these custom-made DIY logic probe boards and connect them to that, and then I've got all the HP high quality probes on a DIY solution. So I think that is a good idea. So although a little bit expensive, it's still a lot cheaper than buying the original Siglent probe thing, you know. But the Siglent probe is very nice. You know, if I was worried about it in signal integrity, that sort of stuff, then I'd probably buy the Siglent one. But to be honest, I don't use the MSO option that often, and if I do use MSO sort of stuff, I tend to do it on the analog channels. You know, I'm usually using like SPI or something like that, you know, and I'll just do it with those. I do actually have some dedicated logic analyzers, which I picked up for nothing actually. One of the review items I had. Where is it? Where is that? Here we go. Got this thing here. Oh, hands on the weight. Yeah, Logic Q probe was 0 plus. This thing's pretty expensive, and I got that for a review. And really nice bit of gear that. But then, problem with these, you have to use them on a PC. So you have to have a laptop or something there running at the same time to be able to use them, which is the trade-off. But it's very configurable. Hundreds of decoding schemes. Handy tool to have. I've used them in the past. I've used them. But for most general stuff, you don't really need to go to that level. I do like seeing a cow and test gear. Yeah. Well, some I picked up recently, which I've got a video recorded for. I've got to edit that. I'm not sure when I'm going to release it. It might be probably a few weeks' time. I'm not quite sure when I'm going to schedule it yet. But I picked up a Datron 1082 7.5 digit multimeter, and I refurbished that a couple of days ago. So I've recorded a video on that, recapped it all, and I calibrated it as well. Roughly, it's not a precise calibration. Everything hadn't warmed up, and I've gone for about probably 3 hours. I think 2 or 3 hours. Everything been on for. So it's a rough calibration, it's not a precise one yet. Only to see what's going on, and that is now in my stack over here. So I've got my Datron calibrator behind me, and the Datron 1082 above it. So stacked one above the other. It looks really nice. So I've got this. I've got that. So I've got two 7.5 digit meters here. So I've got the Datron. I've got the Solotron 1061. So 7061. I always get the numbers mixed up. And then I've got above that is the HP 8457. Sorry, 3457. Which is a 6.5 digit meter. So that's like my calibration stack just there. I've got some other calibrators as well. I've got the Fluke 343A DC calibrator. That's out in my other lab, and I've got the Fluke 5200A, which I'm actually currently trying to sell. Got it locally listed, trying to sell it. That's when I did a massive repair series on, like 19 parts on that, and that's out in the other lab as well. And I've got a Valhalla 2703 AC calibrator, which is sitting on the floor behind me here because it's failed. I picked that up and did some refurbishment on it when I first got it, and it was kind of working. It still had some issues with it, and I did a calibration on it. But knowing it was wrong, I tried fixing it, and it just gone completely out of whack. So that's sitting on the floor here, waiting for me to get around to it one day. That needs some stuff done. Yeah, well, the kind of stuff I'm doing, I'm not doing. Nothing I've got is officially calibrated. It's all basically based on certainty. Certainty. What's the word we're looking for? Not certainty. What's the word I'm looking for? Can't think of it. Anyway, by cross-checking various bits of gear which I've picked up over times and things which I believe to be correct, and cross-checking things, I've got a certain level of confidence. That's the confidence level in the accuracy of the gear I've got. So, although nothing's sufficiently calibrated, apart from the only thing I really know for sure is right is the PDVST Mini, but then I've had that for a while as well, so it could have drifted off slightly. I need a bigger lab to store the gear. Yeah, well, kind of. My second lab is as big as this room, and that's just my stuff. And I've got, you can't see it now because I've got it chatting away, but I've got this set of drawers just here, and they're about, I don't know, 7 foot tall, I suppose, 6.5, 7 foot high, something like that. And yeah, I've got 8 of those out there, and they're about half full of gear, something like that. Bits and pieces, and a lot of stuff is things I've just picked up because I thought they'd be interesting, and I've repaired them or refurbished them, and then I've thought, right, I've only got one of these, I'm not going to sell it, I could be used for it one day, and I've just put it away to one side, you know, thinking one day I'll come across a time when I need to use something like that, or it's used in a calibration process for another piece of gear. Some of these things I've picked up because of that, because they mentioned in a calibration process for something. And I thought, right, I'll get one of those because then I'm using the right gear for that process, you know. But you can't have everything. But the main reason I do it is because I want to make videos repairing things, and to do that you have to buy things, and then it's hard parting with them. That's the problem afterwards. Selling stuff, well, that's I won't sell internationally because it's just a bit of hassle. Although I buy internationally because I have to buy stuff from the US. Most of my stuff comes from the US, sometimes UK, sometimes Europe, but majority is from the US. And that's fraught with its own problems like massive postage prices, which makes it quite costly. But trying to sell stuff, I sell it locally in New Zealand. So anything I'm trying to sell is on Trade Me. So if you look on Trade Me, and you'll probably find my stuff I'm selling on there. But yeah, the problem is New Zealand's a very small market for test gear, so trying to sell stuff over here, if I do sell it, it's not sold for as much it would sell for overseas, sold for low value, and it might take months and months to sell something because it's a matter of finding the right person that happens to be looking for that piece of gear at that time. And internationally, obviously, you've got much larger market, whereas New Zealand is very small, so you don't have the same kind of exposure as you would otherwise get. So yeah. But if I can sell it for as much as I paid for it, and what it cost me to fix it and sort of stuff, I break even, I'm happy with that because I've used the item to make content. So I do try and make a bit of money, if I make $50 on it, it's something. But generally, as long as I break even, that's what I'm aiming for. But it's pretty hard sometimes trying to get stuff done. Hey George. Well, my cats are here. One which was asleep has woken up and come and see me. Yeah, okay, so let's actually do something. I've been waffling for half an hour. So, because of the new eBay payment. Yes, was it some PayPal? Was it PayPal thing, wasn't it? Some issue with PayPal, something, wasn't it? I don't remember. I did hear something about it. I don't remember what it was. Yeah, so nothing has affected me yet, apart from postage prices just going up and up and up and up and up. I mean, there's a lot of times where the postage is more than the item I'm buying. Lots of times. Part of the problem is that because test gear is generally quite large, the sort of stuff I'm working on is late 80s, 90s kind of era, so it tends to be quite bulky. Fairly heavy, robust sort of stuff, as you guys would have seen. So, that means that postage is expensive. I mean, it'd be things I've seen, which I don't know, might be, say, $200 for the item. Think, oh, that's not bad, I'll buy that. And then you look at the postage. Postage is $500. Yeah, I think I'll skip it. You know, that kind of thing happens. Sometimes you just have to live with the cost, because, like, my calibrator here, and I got that, because that is 35 kilos, that thing weighs. I was determined to get this calibrator, because I wanted one. I've been watching for one for a while. It came up, and I thought, right, price looks reasonable, even including postage, and I just had to live with the cost, you know. I think the calibrator itself was... I got it reduced as well when I purchased it. I managed to negotiate a slightly better price. Basically, by the time I got it, the price had doubled. So from the time the cost of the item to the postage, the import duties, to me getting it, the price doubled. It's twice as expensive. So it's about $2.5 grand I think I got it for, and it cost me $5 grand all up by the time I had it in my hands. So yeah, expensive that was. But I was determined to get a calibrator. I wanted that one. And, you know, a working one on eBay is worth 10 grand. So, you know, well, that cost me $5 grand. It cost me probably $100 to fix it, I think. Probably, maybe more than that, actually. As tantalum expensive as tantalum capacitors were expensive. I think it's about $200 in parts, I think I maybe put into it. So, that's good, because I'm drinking a lot. I don't normally drink much for you. I only have a can occasionally, so I don't think too much of this. As you guys, you know, normally in my videos I've got a cup of coffee, but I thought I'd have a V instead, because it's make a change. So let's do something. So go do mailbag. We'll get those recorded. There's a lot of stuff there. Could take a little while actually. So I'm going to do 2 mailbag videos. I've recorded 2. That will give me at least footage for the next couple of weeks. I haven't been buying much stuff recently, so my mailbag items are much reduced than normal, so I'm actually, be a bit more careful how to do stuff. So I've ordered some more stuff recently. And do that. So then we'll figure out what we're going to do after we do the mailbag videos, alright? So those will take a while, won't take too long, probably, I don't know, 20 minutes, half an hour, I suppose, depending on how much we dig into it. And then we can work on either the Datron 1062 and do a refurbishment on that, or we could work on the Siglent 7075 and potentially replace that input socket. How that goes, I'm not sure yet. I'm not certain the way I've got in mind is going to work. It might not. So that's the choices. So give me your opinions. Which one you want to see? After we do the mailbag, we'll do the Datron or the Siglent. The Tron or the Tron. Yeah, thanks Thomas for that comment too. It's appreciated. Yes. Datron. Okay, 1 vote Datron. Come on people. Up to me. Oh, come on. I had the Datron sitting here for about... How long's that been there now? At least 2 months. Yeah, I've had it sitting there at least 2 months now. I started trying to wait for a while. It was the first Datron I purchased before I put up the 7061. 2 votes of Datron. Okay, it's looking like it's going to go that way. Okay. Yeah, a 7075 I had that for a while. So when I sell that, that'll be on Trade Me as well eventually. Once I've done this input connector. Hey Kimmy. Yes, once I've done the once I string a sentence together. Once I've done the input connector, then I'll chuck it on Trade Me, and I'll either have a Ian's here. Cool. Ian's actually done one of these. So Ian's actually done the input connector on a 7075 himself. He did that. Was that 2016? Was it? I can't remember. It was. It's a few years ago. And he used banana jacks. Whereas I picked up a really small, probably probably not a good idea, actually, to be honest. A small connector, which is very similar to the original Datron one, but it's smaller. Datron one. Solartron one. Yeah, my bag, just because I thought I'd just do it behind this. Can't even say it, bloody hell. I thought I'd just do it because I'll do a behind the scenes mailbag. Some people like to see the behind the scenes stuff. So, if you guys don't want to watch a mailbag behind the scenes, it's fine. We can skip that and do straight to a repair. I don't really care. I can always clear the desk off. Do you want to skip the mailbag? Do you want to do that? And go straight to something else? Opinions, please. Obviously, Datron's looking like it's winning anyway. So, should we skip mailbag or should we do it? I mean, you get to see the mailbag anyway. Waiting for responses. That's the problem with this low latency thing. I have to wait for everyone to reply because it's not in straight away. In fact, Ian, I'll show you that connector one. I'm waiting. So it's very much like the original Cybertron one. Still in bag, but it's smaller. Of course, it's not going to focus on it, is it? There you go. 5 pin, but it's a proper concentric style, no offset pins or anything. And there is the plug. So it's like a clone, but this is a smaller size. It's a company which makes Fisher compatible connectors. It's from AliExpress, and actually, it's really nice quality. They're actually really good. And they're significantly cheaper. I bought 2 plugs, 2 sockets for, I think it was like $30 a set or something like that. It was not expensive. And what I've done this one here, the socket, I've already kind of prepared it, is I've put some washers on it. Because it being smaller than the original, so I'll just put some washers on. Because what's inside there, as you know, Ian, there's that bracket which the original socket mounts on. I'll take the original socket off, hopefully mount this socket on there, and just run the wires to it, and I've got a plug. The challenge I've then got to find is finding wiring for the plug. I have to get some suitable cable. The only thing I'm not sure about is the voltage ratings, because obviously, potentially it's got a 1000 volt input. So I don't know how this socket is actually going to handle 1000 volts across it. I actually tend to do an installation resistance test before I actually plug it in, and actually get my tester. I think I can do 1000 volts. And see what resistance is across the pins using that thing, in case there's a problem with insulation resistance before you even go that far. Go to the bench. Yeah. Well, mailbag's due out on Monday, so 2 days to the mailbag come out. Well, it's actually not quite 2 days because I'll do it in about 26 hours, 27 hours time it comes out. I'll do it a bit early, because that's when my peak viewership is. Rather than do it on Monday night, I'll do it on a Sunday night to get it early. It just seems to work better. I haven't actually looked at it yet, and I was thinking about that today, thinking I've got to try and find that. Yeah, I have to look that up. I was thinking about that today, thinking I need to look into your suggestion about the high quality cables. Let me look that up now, hold on. I'll just look for you on my email, hold on. Where are we? Which one is it? If I can find it, I can look at it. I can't find it. It wasn't that long ago you emailed about that. It was only the past month, hey? I can't seem to find it. I've accidentally deleted it. Oh, what is this it? Well, this might be it. Yes, here you go, you mentioned it. Mission summary. Yeah, he talked about it, but I don't think actually said where he got them from, actually. He just said I should look at some metrology grade test leads. I think he actually explicitly said any more than that. Yeah, so I can find anyway. Is that mentioned? Okay, I'll have a look. Let's open it up. Nice short. Oh look, it wants a cookie and it's in German. I guess I accept in German. Okay. Right. I will have to look at this. I shall bookmark this. They got a typo in the page. They say cables and it's got CA with the A being capital. And the rest of it lowercase. The title bar is wrong anyway. Yeah, Fisher connectors, yeah, so. But that's what I was looking at doing, is just replacing it with this smaller one, because it's really robust, it's a nice high quality connector. But the only thing I'm not sure about is the voltage rating. Obviously I have to make sure I'm using like opposing pins or something like that, so it's as far away as possible. Which is what the original ones don't do as well, that's why they're like the weird pin out, because they're opposing to get a greater distance between dielectric. So I'll bookmark that anyway. I've got it left to open as well, so hopefully I don't forget it. I'll look at that later on and see what. Oh, there's one there. So there is. €195. Yeah. So that's the problem. The connectors are expensive. Was this? It's like $30. But yeah, still. I mean, if I'm going to be selling it, I'm not too worried about precision. It still needs to be okay, but it needs to be suitable. They got some cable here, 4-wire low EMF cable set. Needs to be shielded though, doesn't it, for what I'm doing? I want a bit of shielded cable because it does have a guard wire. Anyway, I'll look at that later on. I'm getting distracted. You guys aren't interested in that. Probably not anyway. Okay, so we decided are we gonna skip the mailbag or are we gonna do mailbag? There was nothing explicit there. No one said skip it, no one said do it. Oh, we're skipping the mailbag. Are we going to skip the mailbag and play with some test gear? I think we should anyway. What do you reckon? This one of his mailbags, this box here, it's got dozens and dozens of parts in it. Yeah. Okay. Skip mailbag. Okay. One vote for skipping. That'll probably be it. I'm going to skip the mailbag. Let's skip it. I'll chuck all that somewhere else. And we'll play some test gear instead. I think that's a better choice, actually, to be honest. Get some lighting turned on. And I guess we'll find out as well how good the microphone works from a different viewpoint. So, right. So we're going to do the Datron, are we? Let's give ourselves a bit more room. This would have been cool too. You see the name that's on there? It's not in the chat, but this is something I purchased from Tabaka Technologies, Rob. Some nice test probes. You see, I know what's in here. It's test probes for my oscilloscope. These are nice ones. So, bit of a spoiler alert on that one. But this box here has got loads and loads of parts in it. But we'll find out in probably a week or two's time when I do that mailbag. Here's George. This is a female ginger cat, it's quite rare. Okay, so here are some parts to give you a bit of a spoiler, I suppose. These are parts which I replaced from my Datron 1082. So these are the capacitors I normally do. So this is all that's power supply, these are all power supply, and these are off the analog board. And guess what? We're basically going to be doing the same thing. Because they're all the same. Now I have had this open already, so I've had this sitting for a while, a couple of months at least, maybe 3 months. I've actually lost track. And I need to remember if I actually did the voltage conversion on this one or not. It may or may not be converted. I don't remember. You're hunting a bad I-squared teaser bus. And be quiet. Okay, well what I can do for doing the bench over there is swap over to the other mic. Like that. And we'll use the Go mic instead. So hopefully this one is actually louder over here at the other bench. Now this is the sort of thing I wanted to try out as well. Let's see which mic performs best. Like I might end up having 2 mic setups. And having the ceramic mic where I normally sit when I'm doing my computer type stuff. And having the Samsung over here when I'm doing the bench stuff. So that way I've got reasonable audio between the 2 spots. But sometimes what will happen is I will maybe have the bench view going on over here while sitting at the computer, which might cause audio problems. So I'm not quite sure what we're going to do there. Much better. Yeah, cool. So I said, I'm not sure if I've done the power conversion on this thing yet. I can't remember if I've actually converted the voltage or not. So let's flip it over. The screws are already out of it, they're still sitting on my desk over here. And let's see. This has been converted, so this is on 240 volts. That's fine. I couldn't remember what I've done. I couldn't remember if I've done it or not. Now, some of these boards, you probably can't see it too well on that view. Let's get a bit closer. Do a very zoomed view. That should do it. So you've got this EEPROM here. You can see it's got this like double stacked socket going on. Now what it's actually got is an adapter socket. So these actually have a, by the original design, is a 2532 EEPROM. What's the exact part number? I'm trying to remember. It's TMS 2532. Which is a slightly different pin out to a 2732. So what they've actually done, you can actually get these, or at least you could get these at the time, I don't know if you still can, but these are adapter sockets that actually convert the pin out from a 2532 to a 2732 pin out, or vice versa, depending on which way you go. So these are actually 2732 EEPROMs in an adapter to a 2532 socket. So that's what Datron did on those. That's why you got these big chunky sockets on these, because they've got that adapter in there. And it's the same on the digital board as well. I'm assuming I haven't actually looked at this EEPROM yet. I should actually look to see if I'm right or not. Let's have a look. Yep, 2732. That's correct. And the same thing on the digital board over side. I'm probably too close now. And yeah, you can see the same situation here. You've got the 3 EEPROMs here, and you can see you've got these big chunky sockets on there, exactly the same. These are the adapters as well. So the board is expecting a 2532, these are 2732s instead. It's just was it 3 pins? We've got different pin outs. Was it 19 2021, something I think it was. I can't remember exactly which pins it was. There's 3 pins which are different. I was 1821. 18, 20, 21 it might be. I actually made my own adapter when I was doing programming, so one of the units I had before, one of the first Datrons I had, the 162s, I wanted to read the EEPROM from it, and it's a 2532. My EEPROM programmer didn't support the 2532, but it supports the 2732 because it's really common. So I made this adapter to convert the two, so I could actually read the EEPROM and make a copy of it, and allow for conversion to a 2732 if necessary, and that sort of stuff. Anyway, so this is all original. Things we have to do: got to check the battery, make sure the battery's okay. We will have to zoom out slightly. I think I'm a bit too close. Let's go very slightly further out. Hey Johnny, how's it going? So you've got all these caps here. These are all in replacing. These are always bad. Every Datron I've worked on, these Phillips caps are always bad. Now it's interesting because these same style caps I've seen in other bits of test gear, and sometimes there's absolutely nothing wrong with them, absolutely fine. I still replace them anyway, but sometimes you test them and it's still okay, there's nothing really wrong with them. But there's been other gear. I did something, what was I working on the other day? On my Solitron 7961, I did some work on that. And it's got one of these caps in there, and that was bad. Exactly the same. Same style cap was on the analog board of that one, and that was bad as well, so I replaced that. Thinking it's affecting noise on the readings. Could have been, I think this seemed to be slightly better when I changed it. So we've got that one there, and we've got power supply caps. In here, there's a couple of tantalums on the just down here, which you can't, we won't be able to see anyway from that side. Get to them here. Yeah, it's all behind this ribbon cable up here, which you can't see in hammer shot now either. So there's some tantalums down behind there as well. So what I have to do to get to those is actually got to take the GPIB board out. That frees up these flexes. I can get the flexes out of the way, fold them over, and I can get to those capacitors down there. So there's not that much to do on here. It's like 4 electrolytics and a few tantalums, and that's that board done. And we'll check their battery, like I said. But it's quite an interesting unit though. So these actually have an option of a current board as well, so you can do ammeter functions. There's a button just over here for that. None of my Datrons do that. None of them have got that board installed. So there's an empty option bay just here, which is where that board goes in. And it's got this jumper plug here, which replaces it so the signals go straight through. But the 1082 doesn't even have the option. It's got a much larger AC board, as does the 1062 LS101. That also has a massive AC board instead. So you can't actually physically have a current board in there. There's no room for it because it's got this massive AC board instead. But look, the other boards look identical. Like the driver board over here for the display looks identical. The resistance board looks pretty much identical. I think they've got basically higher spec components on the 1081. It's got some more precision resistors in there, high precision ones. The GPIB board always looks the same. Things like that, so they're pretty standard. There are tantalums throughout the boards. I haven't yet come across a Datron which has got bad tantalums. Not the multimeters at least. The calibrators, like the 4700 which I did, they had really bad problems with tantalums. Mainly because of the supplies, because it's a much bigger unit, the supplies are under much more stress. They're having to work a lot harder. So when the capacitors and the power supplies start failing, you get a lot more ripple on the supply rails. That then stresses the tantalums and makes the tantalums blow. These multimeters, so far, I haven't had any bad tants in these. I mean, maybe I've just been lucky, I don't know, but this is like the 5th Datron multimeter I've worked on, I think, something like that. And every single one of them has been fine for tantalums. But what it does have on the back power supply here, which is what I've replaced these ones for my 1082, it's got some 25 volt tantalums on 15 volt rails. So if these rails do get noisy, that's potentially going to stress those tantalums, which is one of the problems the 4700 calibrator had, with all those 25 volt tantalums on 15 volt rail. 15 volt rail gets noisy. I'm going to say it. The 15 volt rail gets noisy. and then the tantalums end up shorting out because they get stressed and then they blow. And, you know, that's it. It shorts the supply out, then you have a whole big cascading failure going on. So, yeah, anyway, but these have been okay for that. I've not had any problems. So I'm not worried about replacing tantalums. Generally, with tantalums, I don't tend to replace them unless I see a bad one. Or unless the part is known to be causing problems in that particular unit. Anyway. So we shall do the power supply first, I think. Actually, no, the first thing we'll do is test that battery. Think about that. I wasn't going to forget about testing the battery. I'm not going to bother recording video on this because I've done these multimeters enough times now to not have to record video. I'm showing the same thing I would be showing before, so I'm not going to actually record video on this. I'm just going to do it. So what we've got here. 3.7 volts, that battery looks absolutely fine. So, not worried about that at all. I mean, I could probably leave it. If I was going to keep the meter, if it's going to be something I'm going to keep hold of, then I might replace it, even though it looks okay. I mean, it's probably got another 10 years on it, who knows. But you just don't know. You just don't know when it's been put in because, unfortunately, on the back of the unit, they haven't changed the battery date or put any notings on the back at all saying when the battery was replaced. So here it says September 92. Well, that's not the original battery, isn't it? So at some point it's been replaced. We don't know when. It could have been 6 months ago. It could have been 10 years ago. Don't know. I mean, there probably is a date on the battery, but to do that, I have to take the battery out. And if I take it out, I might as well replace it, you know? Anyway. Okay, so doing these power supplies is a bit tricky because it is a bit hard to access some of these parts because you've got these shields in the way and things like that. So it's a little bit fiddly, but not too bad. You can kind of get down to the soldering iron without taking too much out. The only hard bit really is where the GPIB board cables need to go. With those have got to come out. So I can get to these capacitors here. That's really the only hard bit. The very first one is that they'd actually managed to do these caps without moving these cables out the way. I think I was able to like work around them. But I'm trying to figure out how I manage that now because I don't see why I'm doing that. Maybe this cable's a bit shorter there. I had more play in the one I've worked on before, I think. So we'll take this card here out and then we'll start working on it. I'll come and check the chat before I start doing that. Is an alternative to tantalums? Good question. I mean, the tantalums are good for very fast transients, if I can say that right. Very fast transients. So they react very quickly. Like electrolytic is good for smoothing, but they're not good for very fast reaction. So if you've got something that's particularly noisy, the tantalum is good for that. But the capacities are generally lower. But they don't like too much noise. They don't like having too much. They don't like being over voltage at all. And I do have self-healing to a point. Tantalums do self-heal. But ceramics kind of, but ceramics don't like any kind of vibration, or they're very temperature sensitive. So if you're in a situation where they get a lot of heat or put on them or something like that, they'll survive fine. But it does affect the capacitance. It does change quite drastically. If you have a ceramic capacitor in an oscillator circuit, for example, which is tuned, if you put any heat on that ceramic capacitor, the oscillator will just drift off hugely. Things like that, and any kind of impacts, they don't like it. It affects capacitance. No, just as it's under that vibration. Obviously, it returns again straight away, but things like that. So I don't know. Ceramics are okay; they're good for decoupling and something like that. But yeah, I don't know, you probably could get away with some kind of ceramics, but tantalums are more of a storage cap, but ceramic is more of a suppression, I suppose. I'm not an expert on caps, but what little I know about them, you could even be wrong. Because I'm not formally trained electronics, I'm just self-taught, like probably most of you guys are too, I suppose. Just figure out stuff along the way. Right, that's my drink finished. What should I do about this camera? I think it's kind of might come out to a wide view on the camera there. Might be kind of easy to see because I'm moving things around a bit. Actually, I'm considering other options. I could go to my recording camera, which will hopefully turn on and appear when I go to HDMI. Let's have a look at this in a second. Once it's on. Yeah, it's there. Right. So what I can do is use this camera instead, then I can control the view and I can see what you guys can see. It's a bit easier to deal with. I can try and give you better shots and stuff as I'm actually doing it. Hopefully audio's still there. Should be, yep. Okay. So let's get this board here out first. Actually, I'll be right back. I'm just going to visit the little boys' room for a moment. I'll suggest you take the same opportunity if you've got it. Okay, let's get stuck into this thing. So let's get this board here out. Let's touch the casings, make sure I'm on the earth properly because I'll be walking around. Actually, I should take the ribbon cables off before I start taking screws out. Let's pop this off. Is this focused even? Yeah, it kind of is actually. Right. Probably getting dizzy now. Pull that cable there out. Pull this one out. Pull this one out. Sorry, wrong one. That one. I want this one. Put that clip back on. Okay. These have got little washers on them, make sure we don't lose those. What I do find the problem with these is when I do have to take this particular board out is the ribbon cable's got little guides underneath the board and they're stuck on with double-sided tape and they can sometimes fall off. So I have to watch out for that, not to try to avoid peeling them off the board if I can. And they've got these little clips here which have to be squeezed. Try and show you that. So there's a little pin on the side there. We have to squeeze in as I lift the board up. Alright. You've got to try and wiggle that through like that. And it's got to work along all three of them, doing the same thing. There you you go. Yep, and that connected there. Must put there. Okay, here's the GPOB board out. Let's put this somewhere rather than damage it later. Well, here are these little holders that hold the flexors in place. We've got to leave these out of here. Now, these aren't too bad. Sometimes these actually put too close to here. And what you find is they interfere, and you actually have to try and sort of wiggle them through and get them out. These ones are actually looking quite well placed, so this one's going to be easy. This when I peel one off, because I'm going to prove myself wrong. Right, so now we can get to the back of there much more easily. It's not making things hard for yourself, is it? Right, shut chat again. Someone hides his Datron. Oh, come on, Ian. Trying to make you off a yes, that's just true. Polymer aluminium. Polymer caps, yeah, maybe. Yeah, the low ICR is quite important because you need to be able to absorb the charge quickly and dissipate the charge quickly. That's why they're used. So yes, low ICR is indeed the correct term. Let's get some things going here. Got my desoldering gun. A new one, which hopefully isn't going to be too noisy. The soldering iron. In fact, I'm getting a bit warm. I'll take this japper off. Getting a bit too warm to have that on now. How's the string going? It has been dropping frames, but it's not too bad. It hasn't dropped any for a while. That's looking promising. I wonder if I can actually put the bit rate up a little bit. Now, this camera might turn off. I'm just warning you now. It has like a 30-minute idle time before it shuts itself off. So if it does that, don't panic. I'll notice it and I'll turn it back on again straight away. So don't worry about that. Okay, so we've got to get these electrics out. First, I'll make sure I've actually got some. I do believe I have. That's a 4700. 4700. 16 volt, yeah. One of them. And we need 1000 microfarad 40 volt. Now this was the problem. Actually, I had run out of those. I've got 25 volt. Now that's a 15 volt rail that's on, I think. Or was that before the regulators? I need to double check that. I've got 35 volt in there. I'll have to double check. I'm sure I've got some, but I have ordered some more. But they're not here yet. So I might better do those ones. The thing is, usually these caps aren't actually that bad. Like the ones I pulled out of the 8200, so 8200, the 1082, which are exactly the same caps. You can see here. They actually test okay. They actually stood alright. So generally, I'm not too worried about these ones because although these are Phillips caps, like the other ones which fail horrendously, these ones usually test okay still. In fact, we could test that now and just verify what they're actually doing. So this is a 1000 microfarad cap and it's saying 1.02 millifarad. Dissipation 0.05. And ESR is 0.08. Nothing wrong with that one. Check the other one. So, like I say, these ones generally are not too bad. They're usually pretty good. I'll get onto it. 1.02 millifarad, 0.08 ESR again, and dissipation 0.05. It's a 100 Hz frequency, by the way. So, I mean, although those caps are old, they're actually still good. I mean, I'll be finding out these power supplies. These ones generally be okay, the blue ones, and but this one over here not necessarily. This one may be bad. So actually, no, I can't reach now. Turn it around. Let's try this one. See, this one says it's 4700. Well, I do have a cap for this one, so I'm not too worried about this one. That says 5.1 millifarad, 0.22 dissipation, slightly higher. ESR 0.07, so again, probably fine. But I'm going to replace them anyway. I'd just like to. And there's one more over there which is going to be hard to get to. I'll just get it from this side. I'll just get onto it maybe, if I'm lucky. Or barely. 10.3 microfarad, ESR 5.9 ohms. So, and that's 150 volt cap as well. Oh, went past it. Dissipation is 0.03. So that cap's probably still fine as well. But I still want to replace it. Now these ones here, these will be bad. So I'm powered up, I might as well show you. But in circuit testing on these doesn't usually go well. You usually can't read these in circuit. That says 118 microfarad, 0.6 dissipation, but that's completely wrong. If I test this one over here, 33 microfarad, 40 volt, it's giving me 23 microfarad, 0.1 dissipation. Here's a 10 microfarad, that's giving 7.7, 0.1 dissipation. So usually in circuit they don't measure right in these ones anyway, but when you take them out of circuit they're completely wacky. This one says 8 microfarad, so they're all a fair way off anyway, but you know, I know these are going to be bad, they always are. So I'm less worried about the power supply than I'm these ones. So I'm going to replace the ones that I can do. I'm not going to worry about the other two until I get those in stock. I'll come back and do it later on. Right now they're fine. So let's replace these ones down here and those three tantalums are here, which I know are bad because one of them's a 6.3 volt. Actually, do I have the right one for that? So 100 microfarad I think it was, or is that what it was? The 6.3 volt cap down there on a 5 volt rail, which is really pushing your luck. I'm trying to remember what I used the other day. I think I had one. Was it 47? I think it needed, was it? I can't remember. I think it's 47. I put 100 in there because that's what I had. I've got loads of 100s at 10 volts. So it's a big, like basically double the voltage in, so it's a bit better. Anyway, I'll be waffling enough. Let's get these things out. So what I've got to do, these caps are actually glued in. They've got some silicon adhesive stuff in there, you know, silicon sealant, which is gluing these capacitors down to the board. So I have to kind of lever them out at the same time. And once I get one in lifted, then it just falls out, basically. It's alright. So let's try and get in here with this. I'll even try and get it kind of focused for you. How's that sound? Kind of focuses around here somewhere. Chat. Hi Andrew, how's it going? Yeah, I thought I'd just try a different streaming time, Andrew. It's you know, my wife's out, she's out with some friends right now, so I thought I'd Datron porn channel. Yeah, I've got a few of them now. Yeah, so my wife's out, so I thought I'd do a stream. I could have been editing some video instead, but I thought, no, I'll do a stream instead. Instead of having to get up at 7 o'clock in the morning. And I thought, give it a try. See how a different time frame goes. Okay, so let's get this out. So what I'm going to do is put some fresh solder on it. George is coming to see me. George is the female ginger cat I showed you before. Bit of fresh solder on those. She probably can't see me doing too well because I'm probably at the wrong angle for the camera. And the other ones down here are kind of awkward, but I can just get to them. Come on. go. So the best technique I found for getting these out, because they are glued in, is to basically grab one end of it and try and get the tweezer in between out of the way, wiping any other components out. And basically just lever off the board and just yank the bloody lead out of the board, because that lifts the silicon off at the same time. So it's a bit dodgy. That's the part coming out. The main thing I'm trying to do here is get the silicon lift off. The lead is out of the board. There goes the camera. Wake it back up. So that lead is out of the board. And now I need to just lift the capacitor up. So basically just trying to break through the silicon. There we go. Now the thing's floating around. Now pull the other lead out. There we go. That's that one. Now, just use this, clean them out. Try and do some, not to block the camera at the same time. Let's see how this goes. I'm in a pretty awkward spot. Trying to melt anything as well. Apart from the solder, of course. Want that to melt. You should really see the position I'm in trying to do this, so I'm not blocking the camera. Yeah, so those two holes unblocked. So whilst that part's out of the way, it also gives me a bit easier access to the tantalums, which are in a row down here. So I'm going to get all those out as well. And also the other capacitor, which is behind it. So I'm not going to put this one back in yet. I'm going to get the other one out first. Okay. So it's an RDE brand cap. I don't know what brand RDE is, I don't know. I think it's a D. Looks like a D. Yeah, made in Germany, or West Germany. So that's pretty old, alright. I think this is 1987, I think. What date code's on this thing? What's the firmware? 1987. July 1987. 8th of July 87. 8th. Look at that. It's 34 years old. Exactly. Anyway, so I'll get this other one out. So it's a 10 microfarad 50 volt. I think I've got one of those. Maybe I don't. Bloody hell, I'm doing really badly with this. Oh no, it is 100 volt. Is it? That's 63 volt. This is 100 volt. No, I've used the last one already. So I can't get it out yet. Bloody hell, I'm doing really badly. I've ordered these parts anyway, I've ordered them, they haven't arrived yet. So let's do the tantalums. I know I've got them. I think I've got them. What is this one? It's a 47, I think. Let's see if I can get this one straight out like this. Come on, melt. Should have put for shoulder on first. Okay. Come on here. That is the 47 6.3 volt tantalum. That one there. So we're going to replace that with a 100 microfarad 10 volt, because that's what I've got. And also, get the orientation correct. You don't want to get that wrong. Now in fact, I've had this tantalum sitting around for a while. What I did last time was I made sure it's going to be okay by powering it in case it's shorted. I'm going to do that again. I've had this tantalum in part store for a while, so I just want to make sure it's not shorted out. So now you can see what I'm doing. So, negative lead, I'll put positive on in case I've got the voltage set to wrong. It's already turned on. It is turned on. It's certainly 6 volts though, so turn it off. Is it going to explode or is it going to be alright? What do you reckon? Anyone going to take any bets? Exploding tantalum? No, it seems fine. I took a charge instantly and dissipated. No, there's no leakage. 9 volts. Yeah, it's looking fine. No problem with that one. But I always like to make sure. Because it's an old one. Otherwise I wouldn't really care too much. So let's just stick this one in. Let's use this solder here. I actually think this might be a used tantalum. I think I've used these and maybe pulled them something, or I can't remember exactly where I got this from now. I've had them for so long. I really don't know. That's that one done. Now next ones I can't use the vacuum pump on, so it's a bit harder. I have to use wick on these ones. Now these are what? I wish I could read that. Let's get the microscope going. So I have it over here. It's focusing here somewhere. Here is it. That's a 22 microfarad, 25 volt. So 22. Got a stack of those in here. These are all 35 volt ones, so I think these are both the same, if I remember rightly. 22 and 22, yeah, because I've got 33s in the same drawer, so I was making sure. So as we go in, I have to use wick on this thing to get this cleaned up, so I need to get a bit of flux on there so I can wick it. In fact, I might pull the other tantalum out first, and then do them both at once, it's a bit easier. Then the wick's warmed up. Like that. Right. Bit of flux on there, makes the wick work better. And unfortunately my tip's a bit small for this. I'll check the chat again in a minute. Come on, get down there. Done. Prefer the desoldering gun, but this works fine. I'll check the chat, then I'll come back and clean this up. Right. There's a not working Datron 1065 on eBay. Yes, I know about that one, Andrew. No reefer caps in the PSU? No, there's no reefer caps on these. Well, there is actually reefer caps, but it's on the analog board, and I've never known to be bad. They always look okay, and they're the silver reefer caps, and I don't seem to have the same problem as the yellow ones do. Wife's out to the porn streaming, yes. electronics porn, yes. Yeah, we're aware of that Datron 1065. I actually messaged Ian about it a short time ago, just to let him know in case he's interested in it. Did some bar hopping first 8 months. Oh, yeah. Helmut, how's it going? Yeah, if you want to give a discussion about capacitors, please do. I know I certainly don't know everything about them. In fact, I probably know very little about capacitors, to be honest. I just replace them when I see them. Because my experience has been, they're old, replace them. Yeah. Yeah, well, it's as if Ian buys it. I mean, I don't know. I mean, I know. I just let him know about it. So when I looked before, it's a reasonable price, worth taking a punt on. I mean, if it actually had shipping to New Zealand, I would be bidding on it. There's no shipping listed to New Zealand, so I'm not going to be bidding on it. And the first person I thought was Ian. I thought, right, maybe Ian would be interested because he likes to fix things too. So, I thought I'd let him know. So I don't know if Ian's going to get it or not, but please no bidding wars between each other. Yeah. And especially no bidding wars against me. If you see me bidding on something, don't bid on me. Don't bid against me. I'm not bidding on that, so it's alright. Won't be buying it, Ian? Okay, alright. In that case, go for it. Yeah. Might as well get it, Andrew. It looks like it's got some problems, Andrew, but some of those will probably be solved by replacing capacitors. And reseating all the ICs. Don't reseat the RAM ICs. Or use memory. Use recalibration. Anyway, back to this. Let's give this a clean. And brush. And I know you can't see much because my arm's in the way. Of course it is. Just be a bit stubborn down here. Problem with this flux I use is thick one, which is relatively cheap. The flux is a bit of a stubborn thing to clean off afterwards. So it's a bit of a problem like that. Works really well though. But because I use my soldering iron quite hot, I've got a very high temperature on it. I tend to run about 350, so that tends to burn the flux quite quickly. Anyway, now we can put those new tantalums in there. The correct way around, of course. I'm sure those holes are unblocked, but how come I can't get the tantalum lead in? That was going through. That was almost going through. I didn't quite unsolder. It looked like it did. I did a poor wicking job there, people. Oh well. We'll do this. There you go, that's through. I thought I got it all. It looked like it had gone right through. Never mind. Do this, shall we? We should do it like this. Okay. Is that one in? got an email. And sometimes I actually put extra flux on these just to help it flow through the board. This time I haven't bothered. I'm going to see how it goes. That's flowing through okay. Sometimes they're a bit more stubborn than that. And the camera's gone off. Maybe it's only 20 minutes, I'm not sure. At least I notice it go click when it does it. So you were sitting there going, there's no video. Yeah, that's all good. Tweezers. Never let these things go flying off. You will regret it. Oh, I dropped that one. At least I dropped it, now where it went. It's out there. Okay. So let's get the other capacitor in. I'll start to do the other one later on. Always make sure when I put these caps in, I always put them in so you can read the writing. And, yeah, that. Come on, I desoldered those, didn't I? Apparently I didn't desolder them very well. I'm doing a really bad job of desoldering today. Is that clogged? Yeah, slightly clogged. There might be something to do with it. It's also gone to sleep as well, so it's a bit cold. It wouldn't help either. Right. It's almost at the temperature. That's better. Trying to melt this bracket. Right. Try again. The correct way around, of course. Well, at least my phone hasn't gone off because I'm actually on call for work again, so I keep on getting text messages and phone calls today. Problems are going on at work. Things they can't fix and they have to phone me to help them fix it. Anyway, thankfully it's not happened for a little while. It's gone quiet. Should have my fan going. Come on. It's probably going to drown me out now. Is that too noisy? Let me know in the chat. Right, so there's just the one capacitor I've got to do down here and those other two there. So that's mostly done. I can get together one from the other side, so I don't have to do this whole thing with the ribbon cables again next time, so that's a bit easier. And these two I can get from that side easy enough once I get those parts to turn up. It's just a shame I don't already have them. So it's back in place. Let's install this board. I can come back to the chat. The same with these Datrons, you have to be careful of is these little plug-in cables I've got. They can go either way around in some cases. So make sure you get it right around. Generally, the wire is in the same orientation on the socket as it is on the board, so those wires just basically go straight over, but not always. I think in most cases they do, but something to be mindful of is you might put those together and find out it doesn't quite go. Let's plug these in before damaging any wires. So the power supply is half refurbished, so that's something. And the rest of it's probably okay anyway, to be honest. Now there is one capacitor over here on the display board right there. That's another 10 microfarad 250 volt. That's just reinforcing this board. I've never had a problem with those. In fact, whilst I've got this still turned on, let's hook up to it and see what it actually says. Again, I need to get these bloody parts turned up because right now I don't have the parts. It says 10 microfarad, well 9.9 microfarad, 0.01 dissipation, ESR of 2.8 ohms, so that seems fine. I'm not worried about that one. Again, no real problem. So some of these caps, I mean, even the power supply ones, I'm kind of thinking I don't really need to replace them because I'm not going to be keeping this meter. I'm going to be selling this one. So you know, it's not like I'm going to have it for 10 years or anything like that. I mean, these caps could last another 10 years. No reason why they probably couldn't. But I just like to have them right to me, so then I know that if I sell this to someone and in a year's time it's still going to be working because the power supply hasn't failed, you know, hopefully at least. So that's that bit done, mostly with the bits I've got available. I should show you this too. See this transistor here? This transistor caused me no end of aggravation. This transistor cost me 2 weeks. You'll see that in that kind of video. That's all I'm going to say at this point in time. So we'll get the analog board out and replace all these caps here. First, I'm going to chat. And I'll turn it off because you probably can't hear me anyway. Right. Okay. Like this stress of watching people find it themselves. Yes, I suppose. Yeah, there's lots of logic analyzers around. The modern logic analyzers are pretty good, actually. I'm not sure about like the things like the voltage level, stuff like that. Like the one I've got here. Yeah, I'm not sure what the voltage levels are on it. I think it's basically maybe up to 12 volts. I'm not sure. I actually don't have to remember. That's one of the reasons I like to use a oscilloscope, because then you've got the analog bandwidth, right? So the analog resolution. So you can actually just, you know, if it's 20 volts, it doesn't matter. Whereas if you're using a low voltage digital logic type probe, it may not like it. Yeah. Okay, thanks so much. Enjoy your dinner. Yeah, Marco's did a really nice video there. I was watching that. I was quite enjoying it. Ian got a mention in that. Hey, Marco, how's it going? In bed on tablets, not so easy to chat. Yeah, it's not so easy on a small screen. I tend to like on my phone here, iPhone 6 Plus. This is what I use. I'll be laying in bed watching videos, chatting with Paul Daniels, when he's doing a live stream, 2 o'clock in the morning, often. So yes. So that's the power supply recapped as much as I can. What it is, because I had the 1082, the Datron behind me, which I did a couple of days ago, I used the stock of capacitors I had to fix that one. I actually did that one first. I really should have done it the other way around, but I wanted that one working and finished with, so I could put it on my rack here. Or it's not a rack, it's a stack, really. So I used the caps I did have, but I've ordered something. There may even be, do you know what? I bet you in the mailbag items. I bet you. I bet there's caps in here. If there's anything in this one. We'll be fair. Could even be in this one. I've ordered caps. It could be one of these boxes. That's not caps, that's chips. So not in there either. Hey Peter, how's it going? Thanks for the $5. Yeah, it's amazing, yeah, 8.5 digit meters. 1989 is when they were introduced, wow. Yeah, there's some amazing engineering back in that era. You know, it's one of the reasons I like the test gear of that region, you know, like the 80s, 90s test gear, because it's usually well documented. Not always, but usually the service manuals and circuit diagrams and stuff like that are out there. You can generally get them. Not always, depending on what it is. And what is in there is usually quite comprehensive. So that's one of the reasons I like working on gear from this era, is that you can actually follow it along, and because it's discrete circuitry which has been all lumped together, you can actually diagnose stuff. In the more modern gear, you know, like current oscilloscope, stuff like that, I mean, it's just an ASIC. It's like, well, you can't do much with that, can you? You know, if it's not a power supply problem, you're pretty much screwed. So yeah, so that's one of the reasons I like that sort of this era of gear. It's well, for starters, suits the way I think, I suppose. Old and slow, maybe. Right, back to this. Oh, I want this view. I probably want to do something to camera to make it from, you know, I was going to go to sleep. Okay. Oh, I've got an email. I was checking that email is. And my soldering iron's going to sleep. Oh, it's YouTube telling me I'm live. Thank you, YouTube. I think I know. It's not actually a syringe icon, it's a soldering iron. It's my logo, miniature logo. So it's a $sign, the logo, to show that Johnny is a member, YouTube member, to help support the channel. Just like in Serious Nix's Peter is there. He's not only a member of YouTube, he's also a Patreon supporter, and he's giving me some more money. Peter's super generous. Really appreciate the support, Peter. So the actual soldering iron icon is really, really small there, but there's actually like different numbers for, I think it's the length of membership, the length of how long you've been a supporter. I think it's what it does. think I say it was anyway. I can't remember now. So the longer you've been a supporter, I think the more little soldering iron icons you get showing up there. Something like that. I can't remember now. YouTube is really rudimentary in that way. They call it a boring spanner. Actually, I wonder what happens if I have a supporter which is also a moderator. What does that do? That's curious, actually. What does the supporter of the moderator do? I have to figure that out one day. The large device for on the bench. Which one? If you talk about the multimeter, then yeah, big multimeter. Hey, George is back. Okay, so let's pull the analog board out and replace these caps here. Then that's basically the refurbishment done. I mean, the other thing I like to do sometimes, if there's any erratic behaviour mostly, is just go around, lift the chips up and just reset them. So what I'd do, say for example I get this chip here, I've got these angled tweezers, so I just lift it up that end, get it up a bit, lift the other end up and just wiggle it back down again. And just do that with all the chips. Right, these do have issues, or have been known to have issues with dodgy connections for the chips, and all, because everything's socketed, which is really great for serviceability. But you can get a little bit of corrosion there, you know, oxidization, minuscule amount, you know, it's very like surface corrosion sort of thing. And just lift the chips up, put them back down again, just scrapes it a little bit, and just does the job. And one of the first ones I had was at the LS101. That had lots of issues with bad chip seats, so I actually I had to resort the chips, and that solved some of the problems with it. So there was some erratic behaviour in that one. So just, like I say, just leave them out. This is a good thing about these angled tweezers, you can use that to get under the chip and just lever it out. Nice and easy, you know. Be careful what you're doing, you don't want to be levering out the socket. You're not going to go underneath the, if you go underneath the socket and lever, you're going to cause all kinds of problems. You have to go between the socket and the chip. So that's what I've been doing anyways. Just quickly go around, it doesn't take long, you know, 5 minutes you can do most of the board, you know, probably do a whole lot in 5 minutes really. And just resort all the chips. Now, like I said, on this board, if you were to do that on here, those are the RAM chips. You do not want to reseat those, because if you lose power to those chips, your calibration's gone. So those ones you leave alone unless your calibration is already gone. But you can do basically the rest of them, you know, all these other street chips, you know, all the MC series stuff, you can do them all. Just leave these four here alone. Those four there, just leave them alone. If you're having any problems, I mean, you might really need to do it, but you may want to do it just as a precautionary thing. Okay, so let's pop this out. Now these little brackets here, these little latches which stop these from falling out, while I get these out, you just push them over sideways and it just relaxes them, and they then unlatch. It's just the easy way of getting them off. So sideways comes off easy instead of trying to lever them out. Just works much nicer. Now, as this is an analog board and it's got precision stuff on it, I should put some gloves on for this, and I will get to that in a minute. In the other units I've done, I haven't bothered, but then I was going to like clean the whole board anyway and do stuff like that. But yeah, it's not really necessary. Alright, so those off. That's off. That's all the plugs off. So this doesn't have screws, this has clips instead. There's little black clips. Now sometimes they're broken. None of these feel like they're broken, all feel like they're intact still. So I'm going to chuck some gloves on before I go any further. Just to reduce contamination, I mean, there's no harm in doing it, is there? Now, how much does a pair of gloves cost? Practically nothing. Versus accuracy of the board. I mean, I generally don't really bother, to be honest, but you know, most things I don't tend to bother. But when it's now, I've got gloves sitting here and they're easy to write on hand, where before they were a bit of a hassle. I didn't bother, but now they're right here, just in case I chuck some on and do this. So, got to pull these little clips here. This just pop up. here is a bit stuck. There we go. So let's lift the board a little bit, gently wiggle it. Because as a recorded video, I'll be doing that little wiggle it just a little bit insert. You've probably seen that. Okay, there we go, that's out. So what we'll do now is do the same thing we'll do the other one with these little press clips on here. Come on. Now, of course, these are a little bit closer together on this board, I think, or the board's a bit stiffer or something. I'm not quite sure what it is, but there's a bit less play on this one, so you have to fiddle with it a bit more than you do with the GPIB board. This one's a bit harder to get done. Come on. Yeah. That was easy. Like the whole gloves thing, I mean, I got stick before when I was doing the Datron calibrator for not wearing gloves at the time, which was fair enough, but I was going to be completely covering the thing with flux and doing all kinds of resoldering work anyway, so I knew it all needed cleaning anyway. So, I mean, the stick was justified, but I was going to clean it anyway afterwards, so I wasn't too worried about it for that reason. Okay, here's the board. Let's move this out of the way. Just move down here. Let's check the chat again. Finger jam, yeah. Well, my desk there is an anti-static mat, so that's sort of earthed anyway. So it's a static dissipative. Is that right? Static dissipative. Why did I try that word? Mat. So that is basically grounded anyway. It serves as grounded. Hey, computer Buddha, how's it going? So, like I said, I'm going to replace these caps here. So we have a 47 microfarad, another 47, a 33, another 33, a 10, and another 10. So the voltages are 25 volts, 40 volts, and 63 volts. And these have these little ferrite beads in them as well. Oh, I think it's got stuck on the bloody wire sticking it. Yeah. Try and focus it. There you go, so little ferrite beads on the side as well. So when we do these, we've got to make sure we put these beads back on the new ones and try not to lose these ones. Losing parts is never good. So let's wake that up. Hopefully. Come on, wake up. Try to wake up the desoldering gun. Just not. Do that in. Okay. So let's see, 47, 33, 10. 47s. I'll just get the parts out now and think about it, and then I don't have to worry about fussing with them. Well, make sure I've got exactly the same part, because I'll put a bootstrap circuit, it's all this stuff it does on the op-amps and analog boards. So that's a 47 25 volt. This one should be the same, but it may not be. But make sure 47 25 volt. Yep, it's all fine. What we've got these is that the adhesive is sticking to the gloves. Don't have a problem with my hands, do I? It's all greasy. Right. Now we'll get the drawer back in. What does the other one say? 33. 40 volts. Use all those. Yep, 33 to 40 volts. 2 of them. That's why I buy so many capacitors. You see me in mailbag with so many capacitors. Actually, Monday's mailbag, which you get in 26 hours time, whatever it is, that will have loads of capacitors in it. And I'm apologising in advance because it's capacitors after capacitors after capacitors. And then it's got some cool test gear. So, bear with it. Right, 10 microfarad, 63 volt. 1063. Okay. I think I'm going to drop my iron temperature down a little bit here. And now I'm going to use my silver solder rather than my less good solder, because this is a precision ball, so it's not like it's just a power supply. It needs to be a bit more critical here. So I'm just going to put some fresh solder on these and I'll desolder them all. I only desoldering this could be a bit of a waste anyway, but this is silver solder, 2% silver, something like that. I should really get my fan going again. Let's do that. The only reason I put fresh solder on is because it helps it to desolder. This makes that easier. So what I'm going to do is going to completely do one whole side, so it's one end of the capacitor is completely soldered. Then I'll do the other ones one at a time or two at a time, something like that. And so I don't get mixed up and that sort of stuff, and I don't have bits flying everywhere. Just easier. I think that one went too well. Yeah, the last few didn't go too well. Might just do those ones again. Didn't flow. Probably rushing it. Give us some chance to soak through more. And the camera just turned off. Now that is an absolutely perfect desolder. You never ever see me do one that good ever again. Oh wait, you didn't see it. Check. Right. It's that beeping. It's just my soldering iron. My soldering iron's got sleep modes anyway, like I'm using a KSGR T12 soldering iron, which I did a review on about a year ago, I suppose, maybe longer. And I've been using it ever since. It's a really good little iron. Good controller. I quite like it. And that's got a sleep mode. It's got 2 stages of sleep. So the first one dropped down to a preset temperature. I've got it set to 100 degrees because it heats quite quickly, so it can actually drop down quite low. And the second one is when it doesn't get any activity for another certain period of time, which we also preset, it will actually go to sleep and actually stop powering completely and just get turned off and just leave the display running. This desoldering gun is better than the one I had before. Yeah, so it stays hot all the time. The switch is just doing the actual suction. And it's a lot quieter. It is now. I've done some work to reduce the fan noise. I've got a video, well, I've got a whole bunch of footage recorded on that one, so there'll be a video in the future showing modifications done to make this better. Putting a front on the switch, a switch on the front panel and that sort of stuff. Changing the fan to one I had laying around, which was marginally quieter. I really need to get a better fan. The one I've got wasn't that quiet. It's only slightly better. Things like that. Just a few modifications to it. Better ventilation. So sucking air through the case, so I'm circulating around the back of the panel. That kind of thing. Right, so I should be able to lift these out. Yep. Yep. No. Yep. Come on. Yep. Yep. Get these little ferrite beads and get these off before I lose them. Hopefully. That's still quite stuck. Now what I've got to be careful is not flicking this ferrite beads into the fan and having them getting sucked and disappearing into God knows where. Come on, wasn't all coming off. Come on. It's being stubborn. Bit of solder on it. Here still wasn't quite desoldered either. Okay, so now let's do a couple at a time, do the other end, same sort of deal, but that way I don't get them mixed up. So I'm going to do the 47s first. Now of course the other thing I could do on here is actually just heat them up, lift the capacitors out and then clean the holes out with the soldering iron. I could also do it that way. If these get stubborn I might even change, but these two just drop straight out, so that's alright. Beads out. Right, so let's get the 47s, which I think were these ones, were they? 47. So it's a bit of a tedious process, I suppose, doing this, but it's not exactly hard. And also it's taken me longer than talking and waffling about stuff and what have you. But so it's taken me longer than it probably would do if I wasn't recording or streaming, whatever. But that's alright. It's not exactly like it's a lot of work. So let's get those bent around so they won't go anywhere. And we'll do the next ones, which are 33s. In fact, for these ones, I think I will use the other technique. We'll pull them out and then clear the holes out afterwards. It might be easier. Right. Good. Now we'll clear the holes out. Not just soldered yet. Come on. Right. So 33s. That's those ones. And of course now I've did it that way, there's still solder on the legs, so I've got to try and get the solder out of the way so I can get the bead off. So maybe in this case the technique probably wasn't the best way of doing it. Okay. I've still got the right one. Yes. Done that before, put the cab down, picked it back up again, thinking I picked up the same one, I picked up a different one. Luckily I did realise later on, before I powered it up, went to go and do the right one, I thought, hold on, where's it gone? There's not what I'm forgetting to do, I'm forgetting to orientate these so you can read the writing on them. That's something I must always do, and this time I'm forgetting. Just spin them around before I solder them. I just like to do that so you can always read what the values are. Try and do it now. Usually much better at doing that. I make it as a matter of course, that's what I do, is I line them up so you can read them. There we go, done. Okay, let's get the next two out. Sometimes set on one edge, you can just wiggle them around and it'll just break the solder. Don't yank on them, because if you yank on them you'll rip the traces off. That's a bit more than that, I think. No, not quite enough. No, don't drop the ferrite. I used to make sure to get the writing in the right place first, not with the other times. Right. Let's check the chat before I do any more. I'll turn the desoldering gun off now. Alright. Sure, the cat using metal detector over there. Oh, that's funny. So those desoldering guns, like the one I had before, I don't have it in there now. Was it the S993 is my original one, which I've had for a few years, and then the one which I got recently, which is the S998, which is like the dual pump thing. But the construction 998 wasn't as nice as the 993. It wasn't as robust. On 993, I had maybe it's design change over years. I don't know, but the actual heating element and nozzle was quite robust to get a wheel on it, and it wasn't really moving around. The 998, as you moved it around to try and wiggle, we could feel the whole heating element moving around as well. It just didn't feel as robust. This thing here is significantly better, and it's a similar price. The trade-off is that you need more bench space, because instead of just having a handpiece on your desk, which is the advantage of having the other thing, then you obviously got a big control unit box you have to have there as well. So that's the trade-off with it. But it works better. It's probably a little bit slower to heat, I think. Don't think it's quite as powerful, but the suction is better. And it's got a sleep mode. It will shut itself off, I think. I don't know. It goes down to 200 degrees at least when it's going to sleep. It will sit there after a period of time. I don't know if it turns off fully. I haven't tried that yet. But the other one will just sit there full heat the whole time. So that's another advantage, I suppose. Switch to a Weller one. Oh, yeah. Yeah, the actual motor's inside the big body instead of the handpiece. That's why it's got those chill, it's got the power wire, and it's got the separate vacuum line running down as well. The actual element, because it's got 3 screws to hold the heating element onto the body of the 998, and it's just the whole thing just flexes a bit. It just doesn't feel as robust. The 993 is a different construction. It's not exactly the same. It's actually different. And it's more robust. It just seems a lot stronger. But I don't know if that's the current 993s are the same or not. Maybe it's maybe one's a fake, one's not. I really don't know. But this has been working better, which is why this is now on my desk, because this just works better. It's a bit more cumbersome because you've got more of the hoses and stuff. It's a bit more, but otherwise it's all right. Okay, let's get back to this. And my camera's just kind of sleeping. Let's make it back up. Zoom in slightly, shall we? Let's do that one. No, that's not what I want. This one. Yeah. So I'm going to put a little bit of flux on these. It will mean more cleaning, but will help it to flow, because it does need a bit more help because of the traces being on the top of the board. I'm going to solder it from the bottom, but what I've found I've had to do on these in the past is to actually flip it over and solder the top as well, just to get the flow properly onto the traces. I just found it seems to be something that requires just to help it get a nicer joint on both sides. Is it focusing right or not? Not really. Again, silver solder. This does mean I have to do more cleaning up if there's any problem. Now, if I could let go of this, it'd be great. Clean it now, even though I'm probably going to have to be doing touching up as well once I get on the other side. Some brush gone. I think this could probably be thrown out actually. I'm blocking the view, aren't I, with my arm? Always. It's always in the way. Yeah. Like I said, more clean-up required. Not looking too bad now. Let's see what the top looks like. Flowed okay. No, actually flowed okay today. That's nice. Often I don't. something the original one has is all these ferrites all kind of positioned to be at the bottom of the legs. I'm not really sure how important that really is. They're on the legs after all, but I usually try and fiddle around with them, try and get them bent in position. So get in there. Okay, kind of there. They're in place anyway. So that's basically it done. I don't need to do anything else to this board. I mean, I say there are some. Normally there's a roofer cap over here, so there's one there like that. Not worried about that. I've never seen any problems with those. Let's have a close look. There's no signs of any cracking or anything like that on those. I mean, it's only low voltage anyway. It's not like it's high voltage under stress, so I've yet to see one of these ones go bad. There's no signs of any kind of issues. Usually you'll see cracks through them if they've been stressed and, you know, if you've got issues with moisture, but there's nothing. I'm perfectly happy with that. Okay. Let's put this thing back together. I'll come back and check the chat. Okay, here we go. Really wish his chats had like timestamps on them. I thought I did actually have timestamps on them ages ago. Pretty sure I remember seeing timestamps on chat. Hey, Frida's again. What time do I want to record this? Yeah, 8:30 PM. Sorry, 8:30 PM. 10:30 PM. That's what time I call this. Right. Oh, George is back. Whole week in a workshop. Nice. Problem is, what I find is if I got time off, right? Time off for me is not an issue. I can just book time off whenever I want it. It's not an issue. I can just do it, right? So I'm quite lucky in my job where I've got that flexibility. If I want to take a day off or two, not an issue. What I find I'll do if I take a day off or 2 days off, thinking, oh, I'll get some projects done. Do you know what happens? Is I'll sit here in this chair, staring at my computer, watching other people's YouTube videos, or maybe listening to some music, or just generally relaxing. I find that instead of getting the things done that I wanted to get done, I actually do less work than I would have otherwise done if I was trying to cram it all into the time I had available to me. It just works the opposite way around. It's not. I treat a day off as a day off. It just doesn't work for me. I have to sort of, if I'm going to do stuff, I need to sort of cram it into the time I've got available to me. Like today, I wasted so much time today fiddling around with things, and I could have actually been doing stuff today, and I did almost nothing. I watched some videos. 185 days without alcohol. Yeah. Self-isolation feels like prison. Yeah, I suppose. Now, I've been quite fortunate because of where I am being in New Zealand. We've only had a couple of lockdowns. It's not been a big deal, and it's been the first time. It certainly felt like a holiday. Right? If it was actually, I didn't mind the first lockdown. It meant I actually got so much stuff done. It's really good. The second lockdown I found more tedious because I wanted to go to work. My company was actually in operation, they were functioning and they were running, and they kind of needed me there, but I couldn't get there because there's a border restriction. We couldn't actually get through the border into Auckland because I live south of Auckland border, and there's a thing there, so if you're outside of Auckland you can't go into Auckland, that sort of stuff. So I had a problem with that, and so I couldn't actually get to work even though my company was operating and they needed me there and provide essential services, but it wasn't good enough apparently. So, and yeah, so the third one, is the third one? Was the fourth one? I don't know, I've actually lost count. But a few little, just small ones, like a week here or there, you know. Ended up being in the motorhome within the Auckland boundary, so jumped in the motorhome, drove up, parked up somewhere in an undisclosed location, and just camped out for a week. And yeah, came back home at the end of it. That table looks old and nice. The one I'm using as my bench, yeah, that's, I don't know how old it is. It's rock solid. It's really old. It's I don't know. I picked this up. I've had this table for, well, God, since I came to the country. I've had this for a long time. So nearly 30 years. I've been here nearly 30 years. This country. So I bought it then, and it was old then. And it's got wear marks on it from chairs, stuff like that. I'll show you. Actually, I'll try and show you. Go here. No, out's the other way. You can probably see at the bottom there, there's a wear mark there on the front where the chair's been rubbing against it. It's got things like that, you know. When I first got it, that middle drawer there, that it's a lockable drawer, the lock was actually locked and I couldn't open the drawer. So I ended up just sticking some vice grips on it and turning it because, you know, that worked. And yeah, unfortunately there's nothing in it. I was expecting to find something interesting, but no, there's nothing in it. That's quite disappointing. Anyway. Okay, let's do some more of this. This camera's going to go back to sleep again soon, isn't it? So, actually, should we check these caps before we move on? We'll do that first before I get them all mixed up. And I'll show you what we get out of these caps. I'll get the yeah, I'll get the DR out. Hold on. It's easy to see on camera. You know, I've got the other one turned on up top there on my shelf. It's a bit out of shot. This is just a bit more tedious to use, at least initially. So, capacitance, series, dissipation, sort of bit I'll do. Right, so this is a 10 microfarad 63 volt. At 1 kilohertz right now. Let's go back to 100 hertz. I always use 100 hertz myself. Yeah. I was having trouble with these caps as well, trying to get readings off them. $31-ish? No, it's not going to do that. There we go, I've got reading now. 16, no, your camera's gone off. Yeah, anyway, it's like unreadable. Next one. It says 10 microfarad as well. .4, it's actually reading close, but 0.1 dissipation. This one's not too bad, actually, it's gone off slightly. ESR 27 ohms, so not so good. Heading off. It's not completely gone yet, but it's heading there. Check this one. So this is showing 16 microfarad, 28 ohms, and this is a 33 microfarad. So very wrong. Dissipation 0.28. This is why I replace these, because they're always bad. This is another 33 microfarads, reading 24 and 0.1 dissipation, and ESR 8.4 ohms. This one's a lot better than the other one was. This one's not too bad, but heading out. Probably one of the better ones I've seen actually, because usually all of them completely bad. This is a 47 microfarad. We're getting 22, 24 ohms, so also bad. Dissipation 0.3, and the last 47, 28 microfarad again, 0.24 dissipation. ESR 13 ohms. So basically, there's only one cap out of all that, which looked like it might have been alright. That's why I changed them. Okay, get me to back up here and put this back in again. Just going to push these little clips on first. Wiggle these things down, these latches. We'll try and get them lined up, then push them down. There you go. You can't just push them down straight away, then hope it will line up. You have to push them first. There we go. Then we'll power it up and see if it still works. If we're lucky, it still does. With these plugs as well, you have to be really careful about alignment. If you shift it off a little bit, I'll show you. It's actually possible to misalign these. They can go off by like a pin, like that. You can do that. Very easily do that wrong. So be really careful about these if you do these things. Make sure they're aligned properly. Because you don't want to do that wrong, because if you do get it wrong, it's not good for the power supply. Hook up the other board from before as well, put that back in. Okay. Pull these latch covers back on again. Come on, get on there. Cooperate. One here still from the other side, because I didn't put back on yet. Okay, that's all on. Right. We can power this up now and see what happens. Nitrile gloves, because I was handling the analog board, which is fairly precision. So I wanted to, as soon as I've got the gloves sitting there, I thought I'd use them because, you know, that's what they're for. Okay, let's change views. Go to that one. Just like Rossman, yeah, you got to look professional way. You got to look like Rossman. Alright, let's plug power into this thing. Who knows, might get magic smoke. I hope not, but you never know. So I've still got, like I said before, I've got 3 capacitors still replaced in this board. There's two 100,000 microfarad and the 10 microfarad, wasn't it there? I'm not going to worry about the one display board, as are usually pretty good. They're not really stressed, so they tend to be fine anyway. I haven't replaced one yet of those actually, I think. I mean, as it is, like I said, I could probably leave those ones as they are, but I'd like to replace them, so I'm going to sell it. I want it to be in good condition for the next person, so don't have to worry about it. The only thing we're kind of debating is changing this battery, you know, whether I should change this or not, because these batteries are like $20 each, so it's a big cost just for a battery. Capacitors, you know, a few dollars, so what? But you know, these things here, like $1 each or something, is nothing. There's no reason not to do it. But when you're getting $20 for a battery, which probably doesn't really need replacing yet, that's what I'll be debating. Okay, so power switch is off. 225 volts, that'll do. Am I forgetting? No, I'm not forgetting anything, that's fine. Getting 23 watts, that's fine. Display, no magic smoke yet. There's still time. Will I arrange it? Now, did all these buttons work? I don't remember. It's get ohms. Yeah. Sometimes these buttons can be a bit funny. Yeah, that's zeroing. Input filter. Current mode won't do anything because there's no board. That's fine, so the buttons are okay. At least sometimes the buttons play up a bit, they get a bit dirty. Sometimes you have to flush them out with some deoxit. So, DC volts. What do I arrange that? Let's get the PDVS2 mini over here. Error 4, awesome. Give it that. I suppose you can't really see what I'm doing, can you? Ian's going to turn me off now because I'm standing upright. Let me just tweak this a little bit. Let's do this. Kind of works, doesn't it? Okay. 1 volt. Nope, it's doing a volt. Let's turn the filter back off. Speed it up a bit. Don't forget, this is all cold. I just turned it on, so it's not going to be right. 2 volts is looking really good, actually. Look at that. 10 volts. Not bad. I mean, obviously, once it's all warmed up, it will actually come up a little bit. These tend to drift upwards slightly as they warm up, so it will probably drift to be correct. So it's looking really good. Now, one thing we do have is the AC input filter over here, right? This is the line filter frequency adjustment over here. If there's a lot of line noise, you will see this fluctuating quite a bit. Right now, no, until I touch it, of course, it's right. But that adjustment, now I might have already done it. I'm not sure if I've already done it or not. But you tune it, adjustment, and you adjust the line frequency, so it's in phase with the clock. That way you reduce most of the line noise interference you get on these things. There is actually a thing in the service manual that tells you where to, which test point to hook up to, which is over here somewhere, and to look at a certain waveform on a scope and stuff like that. I may have already done it. It doesn't look like it's adjusted, because these tend to be round right out towards the top, and it looks like it's down a little bit, so I think I may have already adjusted this one. But then there is some mains interference there, it looks a bit, so maybe I haven't. I'll look at that later on. We can play with it now. I mean, what the hell? Doesn't matter. If it's wrong, it's wrong. Let's get a screwdriver. Show me a screwdriver. Let's have a twiddle. See, to do this properly, I need to hook up to the scope and actually look at that. But you can see how much it's jumping around there. That shows that's completely wrong now. See that? So that means this is completely out of phase with the mains. So it's causing all this interference to be picked up. So it's jumping around everywhere. Right, so I may have already adjusted this before based on how stable it was when I started. It's jumping everywhere there. So I'll play with this later on. I'll tweak that with the oscilloscope. Or do I just get it right just then? I'll put it back to roughly where it was when I started. How's that? It looks like I've tuned it. Oh well, that comes from the old CB days of tweaking things by eye. No, it's not heated up enough yet, but what I'm just playing with is the frequency. So I think it says it has to be on for like an hour or something before we adjust it, so it's all warmed up. And I'll be inclined to put half the covers back on again. You know, I'd like to put the bottom cover back on again, leave it on for a while. Needs more tea. How's it going, ZX? Next up, Rossman, next up is crotch cam. I have had crotch cam incidents. Sometimes because I wear my camera next to the bench, and if I'm standing up there doing something, then sometimes you do get a bit of a crotch cam thing going on there. Nobody wants crotch cam. Well, I mean, give it a bit more time. It's looking pretty close there. But I need to hook up the scope to it, to the test points, once it's all fully warmed up and stabilised properly, and look at it then. But yeah, it's looking pretty good there. It's not too bad. But you saw what it was like when it's definitely wrong. You saw how much noise there was on the main, then the actual clock cycle then is just jumping everywhere. So it's probably still not quite right. No, there's still a bit of movement there, so it's probably not perfect, but it's really, really close right now. But yeah, I took up the oscilloscope to it and did a proper alignment to that. Yeah, the crotch cam incident. Yes, Fred. Yes, I can imagine that's not great. Can I fit mid-block into it? Oh no mid-band stuff. No. But you can see it's still drifting upwards. Like I was saying before, it's getting closer. So I go back down to 1 volt again. If one needs to buy one of these, go to ianjohnson.com. Go and buy one. Just saying. Really handy things to have. So there's the 1 volt one, which is more likely to show up noise. The lower the voltage, the more likely it is to show it up. So that's not too bad there. And there's no magic smoke. That's the best thing. Oh dear. So your key for the SMU is still broken, is it, Thomas? That's a shame. What model number is that one? Is that 2000 something or other, is it? The adjustment is a metal can inductor. It's like you get in the IF stages of a CB, the same type as that. So it's adjusting the oscillator frequency. It's got like an oscillator there, and it's just adjusting that frequency there. So the clock frequency of the multimeter matches the line frequency. So there's no discrepancy between the clock and the line. That way, or division of that at least. That way any noise is synchronized, and so it's always taking the measurement at exactly the same point in time. So any noise is basically null. 2403. Okay. Now I'm looking it up. Oh, it's a graphical one. Now I have to go to eBay, don't I? Find out what they're worth. Not eBay, not Google. Come on, eBay. No, for fuck's sake. Just go to bloody eBay. I'm in the wrong browser, that's what it is. Oh, let's change browsers. I don't like Chrome. Right. Here we go. Because I'm trying to do searches. Right. No except matches found. There's none on eBay. Wow. No schematic anywhere. Oh, that sounds like a nightmare. There's not even any T503s on eBay. I'm really surprised by that. There's 2400. Some of those. So it's like 3 to 4, 6 grand, 5.5 grand. Something you really want to get fixed, isn't it? That sort of value. 4 grand for that one. This is obviously New Zealand dollars I'm looking at here. 5.5 grand, 4 grand, 5 grand, 4. Panel extension, $50. Rear panel. Interesting. Yeah. It's a quick start manual. That's not much else here. Manuals and software. Keithley model 2400 source meter service manual. Revision B. One of it's got circuit diagrams in it. Doesn't say. Just says service manual, doesn't say what's actually in it. That's a shame. But that's $20 US. In case you're interested. Look on eBay for the service manual. Maybe you get lucky. Unless the service manual doesn't actually have that stuff in it, which is entirely possible. Oh dear, Kay. Oh dear. Got to keep the wife happy, man. Have to keep the wife happy. Yeah, so do you actually have a service manual for that thing at all? I would imagine you do have a service manual for it. Because that could actually have the circuit diagrams if you're lucky. Or maybe enough information to help you. Sometimes there's enough like block diagrams, stuff like that can guide you in a direction. So it's got an email come through. It's just an EV blog thing about Multimeter. It's fine. Okay. Well, it's working, and you can see it's drifting upwards gradually. So calibration's not right, but then covers aren't on, so it's all going to be different. And but at least it seems to be working. I will tweak that properly. I'll get the. Should we do it now? We should do it now, shouldn't we? We'll scope it and stuff. We could do that. Let's do it. Let's get the manual out. Instead of doing a half-assed job on this, let's do this bit right at least. Okay, Datron. This is a 1062 service manual with parts list. I think that's the one I need. That's got everything on it. Let me find this. I'm checking the top screen so you can see what I'm looking at. How's that? I'll get rid of that window. way so I can see what I'm doing. Right. There we go. And I should probably make it bigger so you can see what I'm doing. That's been glitchy. Why's it been glitchy? Why it's been glitchy? Weird. It started getting glitchy when I hit the Google window. I had the Google Chrome browser window open and I hit it. And it got glitchy. Maybe I'll unhide it, shall I? Alright, where are we? It's in there somewhere. Self-test. Change in line frequency 51. 4.1.2. Let's go about halfway. Probably too far. Right. Done the voltage. Line frequency is here. Don't have to worry about doing links because it was set at 50 Hz anyway, not 400 Hz. I've already checked for that. So place instrumental hold, adjust L2 digital assembly so TP7 is 1.05 volts plus or minus 0.03 volts with respect to digital common, TP28. Got that? I can make it bigger, 6 it. It contains about 200 millivolts peak to peak high frequency noise. Yeah. So it's actually not an easy adjustment to make because it is actually hard to interpret what it means because there is just a lot of noise there. So yeah. So if you do it on a scope or multimeter, you might get slightly different results. So we'll do with the multimeter, see what we get. Then we'll look at the scope and see what we get. How's that sound? Turn the camera back on again because we'll use that. Wrong number, heading the box so long. Oh dear. So is it 2400, is it? Oh, 2420. Oh, okay. Had it for 3 years, no progress. I'll give you $20 for it. Joking. That mean it. Now I need to go and look this one up, don't I? 2420. These are even more expensive. It's like 6 grand, 7. Wow. This one wants 9 for it almost. Not a cheap unit, is it? I can definitely see where you want to get it sorted out. There's a service manual here for this one. $71 New Zealand, whatever that is for you. There's another one here for 35 as well. What does this say about what's in it? Does it say? Doesn't say. No, it doesn't actually give you a list of what's inside it, which is always great, isn't it? What's this one say? Sometimes you get like a list of all the pages, like the page indexes will be shown in the pictures, so you get an idea what's in it. Doesn't say either. So yeah. Here's another one. Here's another one. There's lots of service manuals. This one appears to have a diagram in it. It's some kind of diagram. It looks like it's a mechanical diagram, not a electrical one. It's only just a small section of it showing up. Next one here. This one's still sealed. It's wrapping. It's brand new. I don't know. Have you got a circuit diagram? I mean, circuit diagram. I ain't got circuit diagrams. Do you have a service manual for it? You got a debt for €600. Oh dear. So it's not even happened on you. You've got to try and figure out what's happened to it in this past as well. That's always not a great deal. Not always easy. It's got a block diagram and a full schematic. Oh yeah. Yeah. Damn. But it would be a good deal if you could have got it fixed. I hope it actually ends up working out for you. Because value-wise, these things are expensive to buy when they're working. They're not cheap. I can certainly see why you jumped at that opportunity to try and get one for €600. But you can't win them all. I mean, I think I've actually had really good luck. So all the stuff I've been buying, I'm just thinking that I think there's only one time, but I purchased something I couldn't fix it. I've just been incredibly lucky, and that was because it had a bad analog meter on it. The actual meter was bad on it. It's an open circuit. I even had it under the microscope and stuff. I think I did a live stream actually a couple of years ago, probably now. And actually under the microscope, and it was trying to see me. I was actually looking at the wires on the winding of the meter movement and stuff like that. And I was using my my diesel microscope, a really high powered one, which is down here. What the hell was that thing? My Ekins microscope. I was using that. Yeah. Hey Ted. Okay, well what I'm looking at here is I've just recapped a Datron multimeter. I shall show you here. There it is, sitting on the desk. So I just replaced the capacitors in that as just a maintenance type task. I just like to do that for old gear. I just tend to do it as a matter of course. And now I've just got it just sitting there right now with 1 volt going into it from PDVS2 Mini. And that's a voltage reference, adjustable voltage reference made by Ian Johnston. And I'm just watching the meter really and just seeing what it's doing. And what I'm looking at doing right now is adjusting the clock frequency, so it's in line with the mains frequency. So in order to minimise mains noise on the readings, you have to adjust this so that it matches the frequencies. So that's what we're going to be playing with in a minute. Floating stuff everywhere. Yeah, I can imagine. Okay, well, let's finish what I was doing with this. Let's go to here. Use that camera. Hello, George. And we shall do this test point stuff. So let's just tweak this up a bit like this. So I have to put it on hold first. But when I've done this before, having it on hold and stuff didn't seem to matter. It didn't really change the reading. I don't know why they worry about it. I think it's because it's potentially stops any noise coming through from the clock circuitry or something. I'm not quite sure, but it seemed to work fine. Not actually holding it, but that's what it says to do. So let's get a multimeter. This is 1.05 volts. Let's get a better multimeter. This one's okay, but I've got... Where's the other one gone? I think I'll put it away. George, out of the way. I don't know why I'm telling the cat to get out of the way. She can't hear me, she's deaf as a post. I think she gets a hint from me nearly standing on it, really. So, we'll try it with this first, then we'll do a scope measurement. Try and get us not getting blinded by the lights. So TP28 is the common ground point, which, if I remember rightly, is right there. And TP7 is here. 0.79, 0.8 volts we're getting there. So what I should do is put some clips on these and I have to hold them, and then we'll do that again. Hold on, I've got some clips here. It. It's always handy having those little adapters and things like this. Really handy things to have. Okay. So that's what we're getting there. We should be getting 1.05 volts. If I'm on the right test point, I think I am. I don't think it's this one. I think it was... Yeah, I'm sure I'm on the right one. I'm sure it's TB28 just there. I know that's the right one because that's the only test point in the area. Right, so let's adjust this again. And we'll do it on here, then we'll look at the scope as well and do the same thing. So I was really close there. That was barely any movement at all. Come on, I went a little bit too far. Trying to overcome the drag in the actual adjustment. Let's say plus minus a little bit. Can't be all said now. Come on. Oh, come on. I should have left it where it was to start with, eh? Yeah, that's close. Let's try that. What did it say there? Plus or minus 0.03 volts. So, yeah, I'm within that. That's fine, according to the multimeter. Let's unhold this. We should put the PDB2 back on again. Even I turned it off just now. I'll turn it off. I should just left it on. Right. Plug that back in. 1 volt. It's going to take a bit of stabilisation time because I did turn the PDBST Mini off. That actually looks noisier, doesn't it? So even though I'm at the right voltage here, it's noisier. We give it some settling time. In case it's the PDBS2 Mini just settling down, because it does heat up the reference and stuff on it. But that looks worse. It could be because I'm still hooked up to the test point. Let's unhook this. Yes, what it was, because I was still hooked onto the test point, is obviously inducing noise into it. That's better now. Okay. So that works out right. So what we can do now is actually have a look on the oscilloscope and see what that says actually is. Let's fire this up. And do I have this scope on my network yet? I'm not sure I do. I have to go and look at this. I might be able to do a screen capture with the scope with this on. I should have to check. I think I've got it on the network. Once it boots up, I'll check the IP address, see if I've got it on the network or not. If I have, I can do an overlay on the screen rather than pointing the camera at it. And I've got it for my other scope over here. Just give me a second, I'll change views and stuff from that once I'm sure what I'm doing. So once booted up. Okay. Utility. Where are we? System settings, is that under there? Status. No, it's not on that page. Okay. I/O. LAN config. IP address 128. Okay. Web servers should be turned on. Don't have a password on it. Doesn't need it. Okay. Let me check the IP address on this and we'll pull it up. If it's on the network, it will come up. it's come up. Great, it's on the network. So we'll shut this on top screen and we'll look at the screen on my capture here. Let's change the top view. Okay, so it's the Boonton web server on my SDS 2104X Plus. Yes, say no more about that. Instrument control. There's the screen. So what I'll do is I'll hook up the probes to this and we'll see what we get out of it. I'll check chat. And the wife is home, the sounds of it. Oh, she's brought stuff back.
Muffins! Yay for muffins! You're not eating all 4. You have to share. Shut the door on me.
I was nagging about muffins because she made some muffins to take with her to go to the party and she brought some back. I got one after all. Yay. Because I didn't get any before. I'll have some later on, I'm not going to eat them now. Okay. Let's get the scope hooked up. You're kind of on camera because the camera's still looking that way.
Got to take the muffins away.
No, don't take them away. They're perfectly safe right there.
I'll bring one back.
They won't gradually disappear. Okay. Let's hook up to the motor here. Hoping that the probe popping off because that'd be bad. Shorting out stuff to ground lead, usually not a bad thing to happen. Okay. So let's put a hold on this, like it says to do. Let's see, channel 1, we're on channel 1. No, that's not what I do. I'll do that. Push the right buttons. We're on DC coupling right now, 2 volts per division. So we're trying to capture 1.05 volts. So let's just increase this. Yeah, I might actually go to AC coupling in a minute, we'll see. So let's bring this down. You can see there's a bit of noise in there. Is that rippling in there? You might be able to see it anyway. Let's go AC coupling. Oh, AC coupling. That one. I've got a 20 MHz bandwidth flip now. Now let's turn it off. There we go. So there's a ripple in there, which is 1.6381 megahertz. Now there's actually an interesting aspect about this, is that on the Datron 1082, that has a crystal in it instead of a coil, so it's actually fixed. Oh, my wife bought me a muffin. Was it muffin cupcake? I'm not sure it is. Anyway, so that's got a crystal in there instead of adjustment, so it's actually a fixed frequency, and that is 1.6384 megahertz. And so we're measuring 1.648 or 6418 there. So that's actually really close to that oscillator frequency, which is on that crystal and the other one. So that's quite an interesting coincidence, seeing that frequency there. Yeah. Anyway, so let's just do go back to. So what we're getting here, we're getting peak to peak. This is bleeding through here. Obviously, it's bleeding through. 166 millivolts coming through. Right, it's just bled through there. It's not an actual measurement there. It's just leaking through the system. So it's actually not on the oscillator itself. So let's go back to DC coupling again. See what voltage we're actually getting. I'll bring this down. So the mean is 1.07 volts. The top is 1.167. The base is 983 millivolts. So the RMS is 1.07 volts according to the scope. So between the scope and the multimeter, which one do you trust more for the measurement? Oh dear. Fancy doing a podcast? Simple electronics looking for guests, really. I'm not sure now that channel. I don't know what the hell it is. I don't know, I think it's a cupcake myself. I think it's a cupcake. It's sweet. Simple electronics, eh? Now I need to go and look this up. Getting hungry now, yeah. Actually, I'm going to be featured on another channel within the next day, I think. If you're familiar with a channel called My Mate Vince, run by Vince, amazingly, he does a lot of repair stuff, tinkers around, fixes all sorts of stuff, and he's recently started a new segment where he's basically doing a video once a week, I think he does this one, where he's featuring other YouTubers who do fixes. And I actually just said, hey, I'm interested. I was commenting on one of his videos and he read it and he got in touch with me and I gave him some footage to use in an upcoming video. So I believe it'll be tomorrow or within the next 12 hours possibly, I don't know, within the next 24 hours I believe, I could be wrong. Vince will be doing his video and you will see me featured in it doing a repair. It's actually quite a simple repair, it's quite a basic one, it's like it's the opposite of this sort of thing, really, you know. It's like the other end of the scale of... It's still an interesting video. It's unusual, but it's a bit more mainstream, if you know what I mean. So I just happened to have something available, which I was just about to edit. And then he got hold of me and I said, I can do you for this one. So I've sent that to him. And so you'll see that on My Mate Vince's channel. So if you're not familiar with My Mate Vince, go and do a search for him and submit. And subscribe. Right. Anyway. So the web interface on the scopes is really handy. So I can also full screen this and actually fill up the whole window with that view and do the instrument control and stuff from there. I can actually click on things like this in the browser. I'll click on that and bring the menu up and change settings and stuff over here through the browser, which is really handy. And look, if I go in here and change the bandwidth limit to say back to 20 megahertz, it doesn't really change it much. It does bring the IMS value down a bit, so it's 104 now. So it's obviously taking out some really high frequency noise stuff. And that's 105. It's sort of settled down a little bit. So it's quite interesting. Yeah, big 5 on, eh? Interesting. Is that going to play my bloody video? I think it might do. That's right, okay. I'm not sure I'm familiar with that. No. It's Is this Simple Electronics that's got 10,000 subscribers? Is that the same one? There might be a different one, I don't know. Is that the same one? Or is it a different one? This one's got 10,000 subscribers, this one. And hey Ray, how's it going? The scope view, I've only done this, like this particular setup on the live stream once or twice before maybe. Playlist. Oh, podcasts, okay. Okay, right. Yeah, does that podcast. Okay. I don't have them as a subscription, so what I'll have to do is subscribe to his channel and check them out later on. Maybe worthwhile. I mean, networking with other YouTubers is always a good thing to do. It just helps to create a bit of diversity and helps like the cross-linking between channels and gives people more opportunities to find you, and vice versa. It does help. Maybe it's just a talking thing. I don't know about that. I mean, I don't exactly have the best voice. George, you're back. Sion's been on there as well, has he really? I haven't spoken to Sion for a while, actually. I was hanging around his channel for a bit for quite a period of time there, and I think I just moved on a bit. Different, just doing different things. Just doing these, the Picos, wasn't it? Tiny Picos, stuff like that is what he's doing. It's not really my thing, so I kind of just drifted away from him a little bit, what he's doing. I'll drop in there occasionally and just check out his channel and see what he's up to, but I don't really follow him anymore. Okay. Right, so we can see the scope. I'm getting distracted. Squirrels. It's a cat. Does that count? George. Oh, that's not George. This is Paul. This is Paul. Paul doesn't like people that much. She's a very skittish cat. And she doesn't like being picked up. She likes being stroked but doesn't like being touched. She's a really conflicted cat. Like, when I put her down, she's probably going to jump down, run, go outside. Depends if I can relax her enough to put her foot back down. I'll just let her go. She's unsure. She's sitting underneath my chair now. She's not panicked this time. No, she's gone over there now. She's looking nervous. Oh, no, now she wants to stroke. She's okay. But she doesn't want to touch her. Okay, back to the scope thing. So, which one do we do? Do we adjust this frequency? We could do that because we're getting that frequency leakage. Frequency leakage coming through. So we can actually try it. Going back to AC coupling. Let's do it from here. Pull the channel up. Back to AC coupling. I want to change the voltage levels. I'll do it from here. I'll do the time base. Where's the... There we go. Scale. Let's make this higher. I'm going away. I need to go lower. Yeah, idiot. Okay. And time base. We could bring it down a bit. Is it better accuracy or not? No, it might be the other way. So I go 1.639. So, like I said, on the Datron 1082, the frequency is 1.6384. So if I tweak this frequency here, adjust it for frequency, and see what voltage we get. How does that sound? Do that. That's the wrong way. Go the other way. Just trying to gradually do this in little stages. I mean, that's based on the crystal frequency of the unit. There we go, 6384. That's pretty close. See if I take the hole back off. That's drifted down slightly, it's actually gone a little bit too far. Put the hole back on, in case it matters. Yeah, cut slightly again. So, we shall unhook the scope. And look at the meter. And see how it looks. Let's see if looking at frequency is a better way of doing it or not. So it's flicking between 5.3 and 5.4. So that's actually looking pretty good there. So tuning for frequency also seems to work. Okay, thanks Johnny. I shall look at that. I shall just copy that. Put it to one side, make a note of that. Come on, look up. Something to bear in mind, that means trying to do networking like that and getting opportunities for more exposure from other channels is always a good thing. Potentially introduces you to another completely different audience which may not have even heard you before. Simple Electronics I have heard of, but I've never actually followed the channel. I think I've watched a couple of his videos. Anyway, I've got that stored for later on. Right. 7:20 AM, making you hungry. Have breakfast then. Okay. So now we're seeing some jumping around at 5.5, 5.4, 5.6 I saw just then. So that frequency may not be the best way of doing it. Have a look at the voltage again. Let's do it on the meter, then we'll do it on the oscilloscope. Be careful with some of the stuff I'm doing because there is high voltages just here. You can't just willy-nilly stick your hands everywhere. Even down some of these rails there's voltages as well as high voltages. I think this rail's got high voltages on it as well. So you have to be careful. So right down get 1.25 volts on that meter. So that's somewhat different. So it could just be that crystal frequency on the 1082 is resulting in the right timings So it could be, although it's that frequency crystal, it doesn't necessarily mean that's the frequency it's going to run at. Let me do some maths. Hold on a second. Get a calculator. Uh, 1.6384 divided by 50. Okay, so 1.6384 megahertz divided by 50 is that 32.768 or 30.032768. That sounds awfully like a binary number, doesn't it? So it's obviously a binary division. So that frequency probably is the correct one to have. But it could even be that when I'm probing it, I could actually be dragging the crystal frequency down or the oscillator frequency down. It could be dragging it off. So it's entirely possible. Just probing it is making it wrong, and so therefore I'm misadjusting it. Or maybe when I hook a meter up, it's misreading it and that as well. But anyway, let's hook the scope back up. Make sure it's on so it's not going to slip off. Okay, let's get the It's interesting, when I've got that hooked up, it seems to be more stable, does it? I'm not sure, maybe it's not. Okay, top screen again. Back to that. Get rid of this. Close that. How do we get rid of that one? Move it out of the way. Now I brought it up, I don't want to get rid of it again. Okay. That's a good question. Is that that? Yes, it is. Okay. So, we're still getting the same frequency there. So I've closed the measurement windows off, I did. That's what I closed. So let's go back to DC coupling and all that stuff. Bring that down. So again, this is also saying the voltage is a lot higher, so they are disagreeing. So I'm going to bring this back and go to the voltage it says to use. You can see the whole thing is changing by quite a bit. There you go, there it's completely unlocked. That's pretty interesting. Has that means got several different spots where it sits? No, that's unlocked. That's hunting, trying to find it. That's hunting trying to lock, isn't it? That's interesting. Well, I'm going to go to 1.05 again, or thereabouts. No, I missed 1.05. So let's check the frequency on that again. Now I've done that. Back to AC. Oh, tapping the wrong thing. And we'll make that bigger. So that's 1.6401 or so around there. It's jumping around a little bit because it's a bit noisy. Let's unhook that. And let's see if the meter looks stable. It is kind of stable. It has moments of stability, then it jumps, which says to me it's probably slightly drifting out of phase and it comes right. So yes, I'm not quite sure which one to go by. I mean, you've got the service manual side, it says to go 1.05 volts, or you've got this one which says to, potentially do it based on a frequency, which is probably my preferred way. go back to the meter again, which you can't see right now. I know that because I'm not on the correct camera for you to see that. Multimeter says it's 0.99 volts. This we're back on the multimeter again because that did seem quite good before when I had it on multimeter. 1.05 because it's ignoring the noise. It's just basically getting it really close with that because taking the RMS value only. 1.0489. So we're getting a multimeter. I'll switch camera views soon, probably. Maybe. What, George? Alright. Go back to that one. Yeah, I for a while there actually on Southern Big Live, for quite some time actually. I did actually watch him initially, then it got a bit samey, and then I unsubbed for a while, had a bit of a break, and then I'm subscribed again now. I did subscribe to him again, and I just don't watch all his videos. Instead, I just watch, once in a while. We have to wonder how to do the calibration, which way to do it. I mean, the manual says to do the 105 volts thing. So that's what it's set at right now, is at 1.0494, I think it was, sorry, 1.0489. That's what it's set at right now with its voltage. But you think if it's based on a divisor of the frequency in order to divide it down to create a precise timing, it should be based on frequency. And 50 hertz across digital should be something which divides down into a binary number, and that frequency does if we use the same frequencies based on the Datron 1082. I mean, you could assume it's the same. It's so close to being that one that you probably is the right one. Hey KW, how's it going? Nice. See you there before. Well, KW, right now I'm using one of Ian's products. Here is Ian's PDVS2 Mini, which is powering this multimeter right now. Well, providing a test signal for the multimeter right now, I should say. So, yes. Recommended. Highly recommended. Go buy one. Go on. Don't worry about the wife. She'll load to stand. This say it's really important you get one. Ian provides calibration details on these. So when you get one of these PDVS2 minis or the PDVS2, Ian supplies you a calibration sheet and it shows you the exact measurements taken with an 8.5 digit meter of the PDVS2 mini. So you can actually see the exact output, because I mean, it says 1 volt on the display here. That is not exactly 1 volt. This one actually sits slightly low at 1 volt. It's like 0.999997 or something like that. So you actually know exactly what it truly is. Very important, actually having accurate calibration on this number on the screen. Although it's really, really close to correct, it's not perfect because you're dealing with things in a digital domain, and it's not quite, perfect in that way because it's the way ADCs work and stuff like that, or DACs in this case. Get one to fix the hairdryer. I'm not sure precision voltage reference is going to help fix a hairdryer. Oh, I don't know, maybe it did. I'm sure you can find a way. You needed to calibrate your multimeter so you know your multimeter is reading correct voltages to measure the voltages on the coils and the hairdryer. There you go. Anyway. So that's not looking too bad. It's sitting at sort of 5.5, 5.4. Does it pay for shilling? No. No, it doesn't pay for shilling. But I will be honest though, the one I've got here, Ian gave to me. Right, I didn't pay for this one because Ian gave it to me as a prototype unit. He sent it to me at no cost in order to do testing on it and to do like a little review video and that sort of stuff and do some bug testing on it. So that's why I have this one. It is an early prototype. And I think he did a couple of little tweaks to it after I received this one. So it's one of the early ones, which is why I have it. Because Ian generously sent it to me. So, full disclosure. But even if I get the sentence out, even if Ian hadn't sent this one to me, I probably would have still bought one anyway. Because the sort of thing which is really handy to have. Once you've got one, you realise how good it is. Everyone needs to have voltage reference. If you're worried about anything, even if you just want to make sure your multimeter, your basic multimeter is working properly, just chuck it on that. It's really handy. It depends if you want to get to volt in that territory or not. How much down the rabbit hole do you want to go? I've got calibrators here. 7.5 digit calibrators, and yeah, it's a deep hole. Get as a Christmas present. That's good thinking, Dave. Anyway, so it's sitting there at sort of 5.4, 5.5. It's looking fairly stable like that, isn't it? Oh, we've got a 5.6 there. So if there is noise, it's very, very small. We're talking about microvolts there. Talking about jumping up and down 1 or 2 microvolts at most. So it's not bad, is it? So I reckon it's probably very, very close to correct. I'm curious about which one I should be using, or I should just be going by the frequency or be going by the voltage, because the voltage looks close, certainly, but if you think about the binary division of the frequency in order to get timing right, so it's always using precise timing in relation to the mains waveform, then you'd think it would be based on the binary division rather than just the voltage. I suppose when I did this thing, it was really hard to measure the frequency because it's a very low frequency riding on a DC waveform. But I suppose you must measure that frequency somewhere else. It should go through a buffer and stuff. Put a lid on it. Yeah, put a lid on it. Probably change it. It is shielded. Hold on a second. Let me pull. I've got this open. Hold on. It's circuit diagrams. What page was that on? I'm trying to remember now. Don't remember. I'm going to have to find it. Let's look at the circuit diagram for this particular board. What's that last diagram? No, it wasn't the last diagram. It's AC board. I'll find a circuit diagram for this board. That's AC board. And then we'll look at the actual section I'm playing with and you understand what I'm actually doing here. Where are we? Is that it? No, that's Sam's board. Is this it? Hold on, I think I might have found it. Yes, here we go. Let's go to the top screen. So this board here, or this section, is the bit we're playing with. So here it is here. That is the adjustment I'm playing with, and that's the test point I'm measuring at here. Okay, so we've got some varicat diodes, we call them varactor diodes, varicat diodes, whatever, variable capacitor diodes. So these are being used to trim this. So this is doing, we've got a power supply coming in here, 5 volts coming here, master clock coming out here at TP22. So if you look at TP22, that'd be buffered because of these. That's the oscillator, this the buffer amplifier. So if we look at TP22 instead, that will tell us the frequency that we're getting out of it instead. So we should find TP22. TP7 is the DC control from these. So it's controlling the voltage on the oscillator. So it's kind of doing some kind of filtering anyway. Now I do have the filter turned on. So maybe when I have to turn the filter off, maybe it changes it or something. That's Pippi, that's a different cat. Pippi! She's not deaf. Pippi! What are you doing? She gets a bit lost and she meows a lot. Anyway, she meows a lot. She's a bit mental, that one. She's not all there. So what was I saying? Yeah, so this is VariCap diode. So what it does, it has a voltage come through here from TP7, which adjusts the capacitance on those diodes. Let's make it bigger. I have the right window. I can make it bigger. So it looks like this is a DAC, basically, a DAC. It's using a resistor ladder in order to control the voltage coming out. Which is then driving the VariCap diodes, which is adjusting the capacitance across this circuit here, which is adjusting the resonance of this oscillator. So we have a 3 volt supply which is running an oscillator, which means there should be a position supply. TP16 says 3 volt, which is a bit weird. I don't know where 3 volts is coming from. Must be from this circuit here. 5 volts coming in. This is doing regulation of 3 volts here. Okay. So that's obviously the oscillator. This is the output, and it's a buffer and amplifier section here. So, like I said, we can measure here TP22 for the frequency and see what we're getting. That way we can measure it without actually affecting the reading, because having something hooked on here could be affecting the capacitance of this circuit. May not necessarily be voltage or resistance, could be capacitance which is affecting it. So we'll measure the TP22. So first we've got to find where TP22 is. Where's the board layout? There it is. So where are we? As Dave would say, first one to find TP22 wins the internet. Yeah. It's in there somewhere. There's little round circles with lines in. Alright, that's test points. 22, here we go. Found it. I win. Right at the end of M20, M50. So I'll hook up to that and it should tell us the frequency. Let's change screens. Actually, where did I put it? Here we go. Drag this back up here. Same 0 volt reference. And TP22 is that one there, which is probably going to have a higher level on it. It is. Okay, what frequency are you getting there? 1.6383. Sounds kind of familiar, doesn't it? It's not perfect, but it's really close to right. So I shall tweak this 1.6384. So I think this is what it should actually tell you to do, is adjust it for frequency. Made it basically on the fact that trying to measure the frequency on this is not so easy. Wrong way. Too much. I mean, it's easier to measure voltage than it is to measure frequency, so obviously you're basing it on the... Oh, that's really close there. Almost at it. Is it on hold? Let's make sure it's on hold as well. So did it tell you to put it on hold? Maybe the hold stops the VCO from being controlled. That voltage going to the VariCat diodes, maybe it locks it. Come on, I'm near there. This is not the best adjustment. And it just jumped. Of course it did. This is super touchy. I'm going to unhold it. I've just got a feeling having it without the hold being on is probably better. Yeah, this is super touchy. But because it is divided down, it is a bit less critical. Oh, that's almost there. 6.3839. And drifting slightly. Oh, there you go, 4.0. Yep, that's it. I'm leaving it right there. That ain't moving again. Oh, 6.390 now. Oh. It's jumped up 9.7. It's drifting everywhere. I can see why the 1082 uses a crystal instead. That's settled now. I guess that adjustment has relaxed a little bit. Let's sing at 9.7. That's too high. So close. Yeah, this is just a ridiculously touchy trimmer. I mean, they should actually have this buffered in a way so it's got a much smaller adjustment range. They could have had it so for, say, 60 Hz you added a crystal or, not crystal, a capacitor. You could have a capacitor you add in or remove from the circuit to bias the circuit a bit one way or another to make the adjustment range much broader. So, well, a narrow adjustment range but a larger adjustment on the adjustment here, a larger movement on adjustment here, in order to get a frequency trimming which is nowhere near as touchy. Okay, I've got 8.7 there. It's going to give it a minute. See if it jumps. But so because it's got the Vector diodes in there, it does have that tuning option in there, so it's actually adjusting at the same time. So let's hook up the multimeter again, see what voltage you're getting here. And see what we're getting at that point. And see that the frequency jumps and I hook the multimeter on. So it's 639 with the multimeter hooked up. 639.4 without it. So the frequency does change. Yeah, it drops a bit when I put the multimeter on. That's measuring 0.875 volts. Yeah, I think this is going to be basically impossible to get it perfect. Yeah, because I'm getting a difference. There's definitely a difference between the voltage and the frequency we're getting here. So I think I should base it off frequency, not voltage, because that voltage just doesn't seem right. I mean, it's obviously you can get the voltage you want, but the frequency doesn't make sense as far as the division ratio for what I believe it should be, so I'm going to base it off that. I believe the crystal on these was an update or was an option for these, the crystallised one, but or was it just the 107.1 and the 108.1 and stuff that has got these in there? I don't know. Anyway, 6387, that'll do. .638.1, so it's still drifting around a little bit there, but yeah, this could still be a bit of noise getting in there from like mains induced noise getting into it because there's no covers on it. It could be making it throw around a little bit. Looks like a POL. It's basically a POL. Well, it's a VCO, voltage controlled oscillator, which is probably part of a POL system in a way. Right. I mean, we're not talking about tiny voltages here. I mean, we really are talking about almost nothing. So, what we've got now, 1.6405 megahertz. So I shifted up again. So I suppose it's the thing with having that trimmer in there. Is it's extremely touchy. I'm actually really tempted to get in there and modify the oscillator to make it less touchy. They've obviously done it that way so you can trim it across 50 Hz or 60 Hz line frequencies. So it can allow for the different frequencies. Like the 60 Hz has a different frequency, 1.9 megahertz or something. So, which is what my Datron 182 has definitely got, or currently got in there. It's a 1.9 something megahertz crystal in it instead. It needs 6384 megahertz crystal. I've ordered one. I've actually managed to find some, so I've purchased some. So I've got to wait for those to arrive. Oh, I don't know. Right. Okay, that's not bad. Frequency is now 1.639. Well, with the fact that... Should I do it to this one? I don't know, I'm tempted. I believe some of the later Datrons didn't have the trimmer, they had a crystal instead. Like my 108.2's got on it, which is more precision. So I think in that one, because it's a 7.5 digit, they added that because it needed more precise readings for the filters and stuff, and also avoid that really small level noise. But these ones, the accuracy is a bit less critical. Also, if it's a 5.5 digit, it probably wouldn't matter. I mean, talking microvolts. So let's change view now. What we got now? 1.6388, still drifting. There you go. So 5455, it seems to be floating around there. So I mean, am I being too fussy? I mean, it seems to be pretty stable. I think that frequency, I believe, is correct. I mean, that slight variation there now could just be a little bit of a rounding thing going on there. And it just could be slightly still a bit of noise. It's not necessarily changing by 1 microvolt. It could be changing. Oh, maybe it's changed by 2 there. Maybe I'm talking rubbish. But it could be it might be changing by 0.2 of a microvolt, but we've got sort of rounding going on between the digits. But now it's jumping around a little bit, so I could be wrong. Oh well. But yeah, I think that's perfectly good anyway. That's nothing compared to what it'd be like if it was wrong. Yeah, it's just interesting. I thought it'd just be interesting to show that actually. It's quite good. Okay. So it's 1.639. Oh, no, it's going down to 1.6382 now. Just jumped like jump. I'm interested to actually see if that correlates with the noise on the display with that frequency jumping. I wonder if I can see that correlation there. That's 1.636 now. That does make me wonder a little bit about why that's changing so much. I mean, if I wanted super precision on the frequency on this thing, I would hook into a frequency counter instead, you know, because I've got this 1.5 gigahertz frequency counter there, which can have, well, it's got super high precision on it. But the fact it's floating everywhere means to me it probably doesn't really matter because it's drifting. So the super accuracy doesn't really matter because it's drifting by a few kilohertz, sorry. So, yeah. Anyway, that seems kind of alright. I think I'll live with that. But yeah, what I was thinking about before was the fact that I've ordered some crystals for the Datron 1082 because I need to change the crystal because it's the wrong crystal right now because it's got the 1.9 megahertz crystal in there from my 60 hertz system, so I have to change it. So I was lucky enough that someone on eBay had some for sale. It's at least the right frequency. The thing with crystals, it's not just a frequency. It's the frequency will depend on the loading of the crystal. So there's like a stated load capacitance which is used, and I don't know what they are. I don't know what the ones are which I just purchased. So you've got series and parallel load capacitance, things like that. So those affect the frequency of the crystal, what it's tuned at. So I might put it in and find it's wrong. But at least it'll be consistent, it'll be constantly the same, which means it should kind of be alright, as long as it's close enough. Now, also, I have to change a couple of capacitors as well. Apparently, I've got to change. There's a polystyrene cap there and another ceramic cap which needs to be changed. The ceramic is like a 500 volt ceramic cap, apparently, which is interesting. But those need changing, and then that will hopefully get it close. But I can always tweak this oscillator circuitry manually, maybe put a manual tuning capacitor in there if I need to, in order to bring that crystal frequency up and down a bit if I need to change that. But what I was thinking of is that if I've got one of those crystals, because I bought, was it a pack of 5? I think it came as a pack of 5. So it's tempting to try reverse or retrofitting, should I say, or is it upgrading this meter with a crystal, because I know how to make an oscillator circuit. And it's also in the service manuals for the higher versions, like the 1082. The oscillator circuit's in there. It's exactly the same logic board, well, digital board. It's the same board. All I do is change the part layout, stuff like that. So I could strip out the circuitry that's in there, put in an oscillator circuit, and put a crystal in and see how that goes. And this unit this is an experiment. Could be interesting. Stream is stuttering regulate, is it? Okay. It's looking okay right now, not dropping anything right now. Maybe it's not liking something. I don't know. Maybe it's because I've got these browsers open. But the natural YouTube streaming looking okay. Put a camera on circuit, yeah, I'll do that later on. But having it could easily be slight air currents going across it, slight breeze, that could be making it jump around. Okay, Dave, thanks for dropping by. Catch you later. Okay. Thing is, if I put a case on, don't think I can have the probe in there still. Hey Brian, how's it going? Right. Yes, put the cover on. Let's see if I can get it stable by having the cover on. I think the probe might be able to fit in there with the cover kind of in place. I won't be able to get it right down, but it might at least stop any air currents and maybe stabilise that frequency a little bit. Let's give it a try. Let's make sure I can lay these things down first without things popping off. In case I can't even get the probes to lay down. Kind of can. It's not great. Yeah, it's not great. I might be able to minimise it a little bit. I'll just put one on upside down or something. Can't really rest on the probe, it's kind of in the way. It's not great. It's partially covered. It might be enough. Let's have a look. Top screen. What's its frequency doing up here? 1.63761. That is now really slowly drifting. And then it jumped. It's almost like the DAC, DAC, is trying to adjust it. It's now 1.6399. It's jumped up. So maybe it's sensing the frequency and then trying to trim it. Like it's sensing that the phasing's wrong because it could have a phase detector in there. I wonder if it has. Because it even jumped up, and it was before. It's just gradually drifting down. It looked like it's under control, and just just settling down a little bit, and then jumps. Let's have a look at something in here. So we had the master clock, which came out of that. Where's that go? So I can find it. You've got a CMOS clock comes in here. Is that it? Passes through. Comes down to these devices here. Comes here. It also comes around to the clock of the MC4. Was it 14072? Is it or 22? Can't see what it is. Comes around to here. Goes into that NAND gate. Into that counter. This is 14013. 4013 is a counter. That's not a counter. That's a flip flop. Okay, maybe I'm getting something wrong. Right, so got TP6 here, which then comes across to another NAND gate, and this is extremely complicated. And it goes back into here. I'm not going to read the circuit description to understand this. 14013 again, up here. Null detection. Null detection. Okay. So it's probably sensing the noise and then doing a correction based off the clock phase. I'm guessing here. Yeah, I don't know. Anyway. It's complicated. That's master clock coming in, which also comes up here. What's this stuff? Main counters. Clock frequency error detector is built into this thing. There we go. R35, R34, M26, M29, oh sorry, 39, 27. So 26, 27, 39, R35, R34, which I think will be over here. Somewhere. I could be wrong. R35, R34. So yes, those are coming into these correction things. So it is actually making a check of the frequency, and then it's trying to correct for it with this lot through the VCO. Whether or not it's got enough resolution in order to do proper corrections is a different matter though. So be always checking for voltage, because it is actually checking its own frequency and making corrections, which is why it says to use the voltage. So what it's trying to do is make sure that the voltage setting here is within the capture range of the VCO. Yeah. Okay, that's what's going on. So yes, it is a POL, but it's a digital controlled one rather than a phase detector controlled one. It's done in the ZNA 2035. So that's curious. So yes, it's indeed a control loop. But at least we know we're in the frequency range. It should be capturing at that frequency, so I'm going to leave it there. It's obviously tweaking itself the whole time, which is why it's changing. But it looks like it probably changes by too much. Very touchy. Hey, how's it going? 1061, you're close. It's a 1062. Really close guess though. It's because you saw the name up here, didn't it? 62, is that one? Basically the same meter, just different options fitted. Pretty much. There we go, just playing with the oscillator circuitry, like the it's got a clock oscillator in here, which is used to lock it to mains frequency, so it's minimises the mains noise. I'm just playing with that right now, just tried adjusting it and trying a few different things with it, just playing with it really. So we did a voltage adjustment based on the multimeter, we did a voltage adjustment based on the oscilloscope, we did a frequency measurement of the frequency using the oscilloscope, which I'll check up here, like that. Oscilloscope frequency right now, 1.6388, and what's happening is jumping around a little bit. So this one here is jumping much more quickly than the one up here. This is averaging a bit. That is the hardware frequency counter. This will be based on the waveform. So yeah, just like play with it. It's just sort of be interesting to look at that part of it. Basically, I recapped it and just did a bit of refurb on it. There's still some capacitors I need to replace because I didn't have them in stock. I've run out, but not too bad. Yeah, locking voltage. Yeah, so it's basically like a POL VCO loop. It's the POL controls the loop frequency. So it samples the loop frequency and uses phase detection between the feedback from the VCO and its own divider network in order to adjust the VCO frequency. So it's a loop. They can be quite complicated to work on, but also they can be simple in a way. The concept's simple, but because they are a loop, if you have a problem with one, you have to figure out which part of the loop is bad, and usually the easiest way to do it is to break the control loop. So you take the voltage away, so you can't get the voltage feedback, and then you inject your own voltage and see what frequency comes out, and then see if that looks like it makes sense or not. And if you're putting a clean voltage in, which is really stable, you can see if the frequency is changing, that sort of stuff. Andre, how's it going? Yeah, that's my experience of PLs comes from looking on CB radios and the VCO circuitry as I know, and the various different methods they use and those. They're all very similar, but the principles apply across all sorts of things. I mean, I played around POL systems like CB radio upgrade boards where you replace the actual POL with a new POL when you then have to tune the control loops so you don't have runaway situations where it can actually control the VCO properly without jumping around or having too much noise or just losing control and not being able to control the voltage. Whereas the feedback is too slow to come back, and so the POL is too quick to try and change voltage and it just runs off. Things like that. So always can't control it quickly enough. Yeah. Anyway, PO02A, yes, that's one of them. I preferred the Uniden chassis like the MC145, 106, MB8 719, UPD 858, Uniden base boards. That's ones I prefer. I've also worked on the Cybernet ones as well, but I prefer the Unidens myself. I don't like the circuit boards, PO02A boards, because they're double-sided boards, which were quite advanced for the time, I suppose. The Indian ones weren't, and the problem is they have things that wires would break, things like that. There are problems with dodgy wires, and the wires would be underneath components and things like that, and you can't get to them sometimes to fix them, and you won't be able to trace them through. Not the easiest thing to work on, and they had issues as well with like the audio levels. Like, they can't actually run full power on some of those boards because the audio would be too weak, things like that. On the transmit side on AM. Anyway, okay, so I think I'm basically done with this for now. What's the frequency looking at now? 1.6389, slightly high again, but it's slowly drifting down. This is jumping round. I wouldn't really trust this one so much because it's based on the waveform, it's counting it. Whereas this is the frequency counter up here, hardware frequency counter, which goes with the scope. So this is the one you should really be trusting, is this one here. This is gradually drifting downwards. So put a drift down to a point, then compensate, jump up again. So I want to see what frequency it gets down to before it starts compensating. But I think it's actually overcompensating, so I think it's actually shifting it by too much upwards. Could take a while to drift down. Yeah. It's almost like the actual steps in a DAC are too big, and so it's quite a coarse tuning. It's not actually fine enough. My scope probe's on 10 times. I almost never use 1 times on scope probes unless I've accidentally pushed the switch. If I'm using like a BNC cable, so then it'll be on 1 times then, but right now I'm on 10 times. What is my favourite project in regards to what? Like test gear projects or something else? Just generally? It's 1.6387. Still drifting downwards. If I put it on ×1, it will drag it down. It will effectively filter it to 6 megahertz. It'll take the high frequency noise out. Well, I can filter it to high frequency. I want to see what this does. It's getting close to the right frequency. You want to see what happens when it gets there. Bandwidth limit. There you go. Let's do 20 megahertz bandwidth. Taking high frequency noise out. Let's jump up again. I missed it. 1.639 now. and drifting downwards. I missed it. Back to full bandwidth again. Same. So there wasn't a bandwidth affected there. Do like the ability to change it up from here, it's pretty cool. When Siglent first made these web server things available, I did obviously reviews on various scopes and stuff at the time. And this interface didn't work properly on Mac. You click on things, it wouldn't actually click where you clicked. It clicked somewhere else. It didn't align. So it's actually quite nice to know that Siglent actually managed to get that fixed and it's all working properly now. It's only on Mac. PC was fine. Mac was, I don't know, some kind of quirk with the way the Mac was communicating with it or something. I just didn't like it. So it's quite nice they've got that sorted out now. Hey Andrew, how's it going? 706 was it? So now it's sitting at 7673. So, sorry, I should say 1.6373. So that's very down. But one of the things from this though is that you think your mains frequency is always the same, like 60 Hz, 50 Hz, whatever it may be. But it does actually fluctuate. It does actually change slightly up and down. So it could be these changes we're seeing here. This could actually be it compensating for the mains frequency drifting and jumping up and down. It's entirely possible that this is changing because it's latched. It is actually locked onto the mains frequency. It's actually possible. It's back up to 639 now. And very slowly drifting down. It's actually looking fairly stable. It's not too bad, apart from that sudden jump. So it could be the mains frequency which is causing it to it, where it's drifting off. Which makes you think I need to probe the mains frequency to see what's going on there. Do we want to go there? No. That's right, John. It does. It's not constant. That's why these ones which are locked with these loops, in a way, are slightly better than the crystal locked versions because the crystals are fixed frequency, so it's just going to be sampling at the same point in the waveform all the time. So as long as it's pretty much consistent, it's kind of alright. But if your mains frequency is jumping up and down a lot, then it may actually be worse than using one which is like this system where it's POL locked against the mains frequency. So that could be why it's jumping up and down. Maybe there's nothing wrong with this system, but it's because it's reacting to the mains changing all the time. Now I get a 6384 there and it jumped up to 6389. I just saw it. Now it's 95. I need to sample the mains. Do I want to sample the mains? Shouldn't be too hard to do. I don't actually touch anything, I just have to be close. Let's sample the mains. I could make a loop with my probe, create an antenna, put up channel 2, turn channel 2 on, and put this near something mains powered. And hopefully we can get both frequencies on there at once or something. I don't know. Anyway, put it. What a transformer, how does that sound? That should pick that up. Channel 2, what are we doing? Now the frequency is going to be much lower. And it's not picking up anything. Come on, it must be able to pick up mains. Let's do it without the probe looped. Let's just leave the probe loose instead. That's awfully bad. Put the clip onto the outside of the transformer. Let's do that. Right. I'll change your thing to see what counter that's on. I think I can. This hardware function counter is on channel 1. How can I change that? I don't know how to change it. Is it in there? I think so. No. I don't know if I can change the hardware function counter to a different channel. It's not something I had to do before. No, it's not under there. Okay. Channel 2. Was measuring all sorts of rubbish. Okay, let's do it a different way. I was hoping to be able to do both at once, but I'm making a mess of this. So let's not do it that way. Let's just get channel 1 and we shall hook it into this area here. Turn it back off. And I've got measurements all on the wrong channel now. Where's the best place to get noise from? Come on, where's the noise? There we go. So that is just jumping everywhere. That's saying kilohertz frequency. This is not right, is it? can't really do this in this way, it would seem. I wanted to try and cheat, so I'm actually doing a physical connection. But I think I'm going to have to do one if I want to measure that. What if I measure by the input of a bridge rectifier? Let's do this a smart way, shall we? Let's ground that. Bridge rectifier. Here we go. Took me a nice thing of that, didn't it? Bloody hell, should have done this first. But we're still getting some interesting stuff jumping around there. So that frequency is definitely jumping around a fair bit. So that's like 49.98 I saw the stand, and 50.02. It's constantly shifting up and down, which is not unsurprising. So that's probably why our frequency is jumping all the time, because it's constantly trying to adjust to that. Right. Well, mains is kind of regulated. It's what it is because of loading on the line. So where it's generated, it'll be 50 hertz when it's generated, or 60 hertz depending on the country, right? So it will be that frequency when it leaves the power plant. However, as it comes down the various lines, you get phase relationship issues, right? So you got the voltage and current are not necessarily in phase. They start off in phase, then they go out of phase with each other, depending on the inductive or capacitance loading of sections of the network. Also, you get loads which will come on and off depending on the sine wave. So that some loads switch on and off at certain points, like PWM systems and stuff like that. That can cause a distortion to the waveform, and distortions on the 50 hertz will mean it could potentially morph a little bit, and say instead of having a nice pure sine, it might change the slopes, and so it will suddenly slope up more, then come off slower or something like that, which then shifts it out. And again, because you've got the voltage and current relationship in the waveform, those can go out of phase with each other, which is where you've got the real power, reactive power thing going on. This is why you have power factor correction, and in big industry you have capacitors or inductors that get switched, and usually capacitors, which get switched in to compensate for big loads that are on their system, which helps to make sure that the current and voltage waveforms are still in phase with each other at the correct points in the waveform, rather than just like being slightly off. You know, a few degrees of difference can change your actual power versus your reactive power. Is that right? Actual versus oh god, I forgot my name now. This is gone. Anyway, it's AC stuff. I know a little bit about it, not much. Power factor, yes, power factor correction. Yes, right. That's part of it, but yes, and because it's the whole power line system and everything off the power line system, which comes in your vicinity or even past your place, anything on that system can cause interference on the lines. This is why filtering and stuff on equipment is quite important. So a lot of equipment's got filters built into it, so it doesn't backfeed noise back into the power system, that kind of thing. But yeah, so obviously mains noise is distorted, not necessarily pure sine wave. It should be pure sine wave, but it isn't necessarily. and it can cause it to be shifted a little bit as well. So, yes, that's all you can see. It's jumping around a bit. So the best place for me to probe that right then was on the input to a bridge rectifier. So it's gone through the transformers. It's been stepped down. It's still AC into the bridge rectifier, but then you can see there's a bit of noise on there as well from the actual rectifier, from the diodes in the rectifier itself. And the way that stuff works, and a bit of backfed as well from the system. Anyway, it's sitting at 1.00056. Yeah, 5556. So it's looking like stable anyway. So I think it's alright. It's been an interesting thing to play with, isn't it? Have a little look at that and understanding how that works. Bit of a curiosity. Let's put this thing together. I think. Should I put it? I've still got 3 capacitors to replace, but I don't have them. So I think I'm going to have to shut it down. PDVS2's down to 14.8 volts. Because it's all battery powered, you know. Keep the noise down. I'll have to charge that soon. It's getting down a bit low. Okay. Pack all this up. What I think I'll do is I'll just pop the colours back on for now and put it back to one side again, and when those other parts turn up, which shouldn't be far away, I think they've actually been posted already. So when they turn up, I'll just replace those other caps, and then I can button it all up and do the alignment on it, make sure it's alignment, the calibration on it, make sure it's actually reading the correct levels and stuff based off my calibrator. And then I can try and sell this one as well. I mean, I've got is it 2 one of those? Is it 2 1062s I've got on for sale right now already? I've got the LS101 and then another one which had a broken display, which I made that display board to replace. So I've got that. Yeah, I think I've got 2 for sale already, so this will be the 3rd one I'll put for sale. I do have one more which I'm going to keep. So I've got the 1082, I'm going to keep one of the 162s, one of the better ones, whichever one's in the best condition. Maybe the latest version, not sure which one that will be. One of them I've already put a new battery in it, so that's probably one I'll be keeping. So I probably will sell this one. Yeah, I think so. So that's probably what I'll do, is I'll sell this one once I'm sure it's all good. But it seems to basically be. So I'll replace those caps, I'll do that, so it's all fully recapped. Then I've got no issues with my conscience when I sell it, thinking that it could potentially fail at any moment, because it's not likely to fail if you've got new cabs in it. Put this down to one side and wait for the rest of the parts to turn up. They shouldn't be too far away. Yeah, that's an interesting little exploration there, wasn't it? It's always nice playing with something that's a little bit different and just digging a little bit deeper into something you already have a bit of understanding of, but sometimes it's nice just to go a bit further with it and increase your understanding somewhat. You know? Nobody knows everything. Looks stable enough. Yeah, it looks pretty good. Fix the donut. The loo no longer leaks. Cool. Is that one of those big flat rubber seals? Won't just go in the on the flush system, so you've got the flush column, I suppose, which is usually attached, clipped on somehow to the bottom of the system, and then in there you've got a big flat rubber seal. Is that the one you had problems with? Yeah. What I think can happen is if you use, this is my suspicion, not confirmed, based on my plastics knowledge, if you use little like those bleach tablets or whatever in the system to help keep your water clean, as are commonly used, that will actually damage the plastic. Bleaches and plastics, not a good mix. It breaks down their molecular structures and actually makes them shrink. And what can happen with the rubbers, it makes them go a little bit harder and makes them shrink slightly. So what happens, instead of being a nice big, soft, fluffy seal, it will shrink just a little bit and get a little bit harder. And then it doesn't seal quite so well. So if you ever put those bleach tablets and stuff like that in your system, then that could cause that to happen. Yeah. Anyway, so it's now 20 to 1 in the morning. My throat's starting to get a bit sore from all talking, so I should probably call it a night. Thanks, Peter. So I thought it was quite a different thing. I mean, I don't know what do you guys think about the timing? I mean, this is obviously different. Normally I'll be streaming in 8 hours time or 7.5 hours time from now. So what do you think about time over the Saturday night? For me, it's Saturday night. It's better than the Sunday morning stream. I mean, which one do you think is probably the better timing? Better for you? It would be for Ian, yes, in the morning instead of at night. I suppose, potentially. Depends if you're busy in the morning or if you're busy at night, I suppose. For me, I struggled a bit with the internet speed because the speed here is not as good this time of day. In the morning it's better for me, which is why actually when I started doing the streaming, I did them early in the morning because that's before all the network traffic got busy, and so I could only really do it at that time because otherwise network just didn't cope. It would just fail. So, but now my provider's been gradually doing upgrades across their network, and it's gradually getting better and better. And this evening it's been okay. I was dropping some frames. I did have to reduce the quality a fair bit. I had to reduce the bit rate quite a bit. Exclude the pun, I suppose. Excuse the pun. But that seemed okay. It's lost 2,422 frames. So, yeah, I don't know. And also my stepson likes the game, and he games in the evenings and at night. So right now he would be gaming. I think he's gone to bed early, actually. I think he's got work tomorrow, so I think he's already gone to bed. Well, for you, Peter, when I start streaming, it's 3 o'clock in the morning or something for you? Normally when I start? Not the best for you? Lag in chat. Yeah, well that's because I use low latency stream. So you got 3 options for the streaming. You got ultra low latency, which is like real time, very, it's not hardly anything in a couple of seconds or something like that. It's almost nothing. Low latency is what I tend to use, which has got probably a 20-30 second delay. But then you got there's another one as well. I can't remember what it was now. But the 2 slower ones allow you to do recording and DVR recording, so it plays back later on. Also gives a higher quality stream, so it gives YouTube a chance to process the video. So when it does play back later on, it's also higher quality, apparently. But I don't know if that's actually true or not. I'm not sure. But I did try the ultra low latency once, which is like almost real time, and I did have some things I didn't like about it. I can't think what it was now. I think it was something to do with playback. It glitched a little bit. It couldn't actually absorb any like drop frames. It really showed up any problems. So yeah, so the 30-second delay between the time you say something in chat and the time I see it, that's just because of the low latency option. I wish there was something in between the two, so you had like, I'd say 10 seconds or something instead, because that'd be a bit better. a bit of a compromise between the two, because I think moderately processed video would be better than almost unprocessed video. Yeah, it's a case of trade-offs. It's about choosing whether you have better quality video versus interaction, real time. Okay, Fred. Yeah. Thanks. Yes, that's a bit of a choice. I don't know. Maybe I'll alternate or something like that, and maybe do some in the evenings, some in the mornings, and just swap around. So different people get a chance to see me at different times, and actually get a chance to be part of the stream. I don't know. I've had my view counts have been lower. So normally when I stream in the mornings, I might get sort of, I don't know, maybe 40 people watching at one time as a peak. Now it's usually mid to high 30s is what I'll get as a peak, probably a constant sort of high 20s to low 30s. And this stream I've been getting much less than that. I think I've peaked about 23 at one time, something like that. Most people watching at one time is about 23. So it looks like the morning streaming for me is more effective with people, but then it could just be because I'm streaming at an unusual time. People aren't expecting me to be streaming this time of day, so they weren't around, whereas otherwise they might have been. So it could just be that. So I'm not going to read too much into that yet. It might be a case of just doing this again another time, this time of day, and just seeing how this goes, and seeing if I get similar results. But if I'm seeing more people on the stream when I'm doing a morning one rather than an evening one, then that probably says to me that the morning one's a better time to do it, generally. But like I said, I'm not really fixed on it. I don't mind swapping around. The thing is though, I prefer, how can I put this? When I'm home in the evenings, I'd like to spend the evenings with my wife, generally. Or if I'm tinkering with something that's a bit different, she doesn't mind if I'm tinkering with stuff, as long as I do make some time for her, which is, what I should be doing. So, in the evenings, if she's here, I'd probably be more likely to be spending time with her rather than being on stream. Whereas in the morning, she knows that's like the time I'll stream. So, but she doesn't really mind. If I do choose to stream in the evening instead and not stream in the morning, she's still going to get time with me. But she prefers to spend the time with me in the evening because we can sit down together, watch a bit of TV or watch a movie or something like that, which is just a bit better than the time we'd be doing in the mornings. Mornings, if we're playing time together, we're probably doing some kind of work or something instead of relaxing. So it's not likely I'll be doing many evening streams unless it proved to be hugely popular. But based on what I've seen today, it's not much in it. I think the morning stream is slightly more popular, but then, like I said, it could be because people didn't realise that I was going to be streaming at this time of day, so it didn't come online. Okay, so I'm just waffling now, and my throat's getting drier and drier. So I need to go and get another drink before I go to bed. It's like 1:15 now, and make sure I've got everything turned off. I think I do, apart from lights, and I'll catch you all later. I will probably live stream next week. We'll see what we do. So there we go. If I live stream next week, it'll probably be on my usual morning time for me. So it'd be the same, 7 hours time from now, kind of thing. If I stream next weekend, we'll see how we go. And yeah, so I'll catch you later. Thanks for dropping by. Thanks for having a chat. Good to hear from you all. Good to hear your opinions and what have you. And I'll catch you all next time. Bye.